Precious day we're having this statistics revision. It's great. I wish this festival of lights bring all success in whatever uh, examinations or in any field which you are involved in. Okay. With that, okay. How are you preparing? How is your preparations going on? I think it's almost a month after the classes. It's going on fine? Yeah. Okay. Great. Now, with that, why have we why are we meeting today? It's because of revision classes, correct? Revision will be completely discussing on statistics, the complete statistics part of the syllabus. So this is very important because it is for 40 marks. 40 marks will be covered in today's session, which is 10% of your entire syllabus, 400 marks, entire foundation 400 marks, 10%. So very important. Please be attentive, and we are not learning anything new here. Whatever we have learned in the classes, in the normal classes, we'll be quickly brushing that up so that we will be revising it. We will be refreshing our memory so that it becomes easier for us for preparation for the examination. That is the objective behind this. And I'll not be solving any specific problems in the classes. It's only revising the concepts. And obviously, while revising the concepts, I'll be giving some examples for our understanding. Clear with this? Right. Okay. So please be interactive. Same rules apply which were there in the classes. Okay. If you have any doubts, you can still ask. Not a problem. And we will be going ahead. Okay. So with this, shall we start with the revision?
Yes, sir. Yes, sir.
So the entire subject of statistics are divided into 6 chapters. I hope we remember the chapter names at least. Correct? Statistical description of data. Second chapter was?
Measures of central tendency.
Yes, measures of central tendency and measures of dispersion. Third one? Probability. Excellent. Fourth one?
Theoretical distribution.
Fifth one?
Correlation and regression.
Regression. Last one?
Index number.
Excellent. Yeah. So these were the 6 chapters that we had discussed, of which the first 2 chapters, statistical description of data and measures of central tendency and measures of dispersion, are very important from the examination point of view. It covers 50% of the syllabus. So 15 to 20 marks in the examination would be from the first 2 chapters. Then comes the next 2, probability and theoretical distributions, which might be asked for 8 to 12 marks in the examination. And the last 2 set, the last 2 chapters, correlation and regression index numbers, might be for 7 to 8 marks, depending upon the weightage given. Okay, so this is how we will go in the revision session also. This is the order in which we'll learn. Okay, so most of the time would be devoted to the first 2 chapters, statistical description of data and measures of central tendency and dispersion. With that, we can start with the revision. First chapter, statistical description of data, basically the introduction into statistics. What is statistics, what it deals with, etc. Correct? That is what we had learned. Statistics has definitions. It has it has originated from various languages as per their claims. Correct? So we had learned 4 different languages from which it is originating. We had 2 different types of definitions of statistics. Correct? We'll discuss. And we then discussed about what it deals with. It deals with data. So different types of data. How do you collect the data? Correct? That is what we discussed in the first part of this chapter. So we'll quickly revise what we had discussed. Okay, this is the same material which is circulated. First one is definition of statistics. Before the definition, origin of the term statistics. It is originated from, as they claim, 4 different languages: Latin, Italian, German, and French. Latin, it is called status, or it is the original word in Latin is status. Italian, it is statista, and German, statistic. French, also statistic with a different spelling. So these are the 4 languages or the 4 origins of the word statistics. Then the definitions of statistics, 2 types broadly: plural definition, singular definition. Very easy to remember. Okay, we need not by heart the definitions. Plural means more than one. Correct. So more than one means it should be large in number. What will be large in number? Data. So the data collected itself is called statistics under plural sense. Plural noun defined as data, whether qualitative or quantitative, that is collected usually with the view of having statistical analysis. So data collected for the purpose of analyzing it is called statistics. The data itself is called statistics. Singular means one. So it is a process. It is that process which we will employ to collect, analyze, and present the data. This data, to collect this data, to analyze this data, to present the data, what is the process involved? That process is called statistics as per singular definition. So as per plural definition, that entire set of data itself is called statistics. As per singular noun definition, the process involved in collecting, analyzing, and presenting the data is called statistics. Clear with this? Yes. Then application of statistics, whatever we learn in this subject is itself the application of statistics. Various applications. Some of the applications we'll discuss, correct, in the subsequent chapters. Coming to the next part is limitations of statistics. Statistics, yes, it has various applications, wide range of uses, but doesn't mean that it does not have any limitations. It has limitations also, correct? We learned 4 limitations of statistics. First one is deals with aggregates. Means we should have more than one information for the purpose of statistical analysis. If I have height of Mr. A as 150 centimeters, can I do anything with this?
No, sir.
No. Only if I have height of Mr. B as 160 centimeters, I can compare, I can find out the average, standard deviation, etc. I can do statistical analysis. So for statistical analysis, I have to have aggregate of data. Single data is of no use. Okay, so it deals with aggregates. That is one of the limitation. Second one, it is concerned with quantitative data. So in all the applications of statistics which we learn, all involve numbers. Only if we have numbers, we can have further analysis. So it is concerned with quantitative data. Qualitative data is difficult, or it is impossible to analyze the qualitative data. If you want to analyze, what you have to do? Yes, we have to convert it into quantitative, right? Therefore, the second disadvantage, it's concerned with quantitative data. Third one, future projection under specific conditions. So in regression, we had learned, we make future projections. When we are making future projections, we will presume a specific condition. If this condition is satisfied, yes, my projection might be correct. But if this condition is not there, subsequently, if the condition changes, my entire projections will go for a toss, right? Therefore, that is one of the disadvantages. The future projections that we make will be based on a specific condition. If that condition is not satisfied subsequently, then the entire projection that we make will not be correct. Third limitation. Fourth one, theory of statistical inferences is built on random sampling. So all statistical conclusions, statistical inferences that we make is based on an assumption that the sample that we take is random sample. If this concept of random sample is not followed, then the entire conclusion that we have made, all the models, all the theories that are built in statistics are based on a presumption that the sample is random sample. So the entire model that we have applied, the theory that we have applied to get the conclusion would be wrong. Therefore, this presumption has to be followed. If this presumption is not followed, if the sample selected is not a random sample, if the procedure of selecting random sampling is not followed, then the inferences would not be correct. The conclusions would not be correct. These are the 4 limitations of statistics. One is it has to be aggregate, more than one. It should be quantitative. The future projection based on specific condition, and it should be based on random sampling. These are the 4 limitations of statistics. Having
Sir?
Yeah.
The recording is not going on.
Okay. We'll just check that. No, I think it is paused. Okay. Okay, fine. So that is basics about statistics. What is the definition? What is the limitation and applications of statistics? Now we have to move further. Further, if we have to move on, we have to understand the concept of data, because statistics is basically all about data. Correct? What is data? Data is quantitative information about some characteristic. So any numerical information that you have, that is considered as data. However, in certain cases, qualitative data can also be converted to quantitative by giving numerical description, by allotting numbers, So that is data. Any numerical information will be considered as data. Data can be broadly divided into, or quantitative data can be broadly divided into variables and, data can be divided into variables and attributes. What is variable?
Quantitative.
All quantitative characteristics would be called as variable. Qualitative characteristics will be called as
Attributes.
would be called as attributes. So attributes, qualitative, full stop, no further discussion with regard to that. If you want to have statistical inferences, convert it into variable, give numerical descriptions to them. Variable is quantitative. When we are analyzing the variables, we'll further divide variables into two types.
Discrete and continuous.
Discrete and continuous.
Continuous, discrete and continuous. So what are discrete variables? Discrete variables are those variables which assume
Finite number.
Number of variables.
Countable number. So we will be in a position to count the number of values that that particular variable will take. Correct? They are called discrete variables. Continuous variable means those variables which take
Can we assume any value in the interval?
any value in the given interval. It can assume any value in the given interval. Best example is height. If I say the height of students are within the range of 150 to 180 centimeters, then it can take any value in between 150.555, 155.6, correct? Similarly, 165.22, any value it can take in that given interval. Hence, they are called continuous variable. So two types of variables, discrete variable and continuous variable. Discrete variable assumes a finite or countable number of isolated values. So they are called discrete. Example, number of petals in a flower, I can count. Correct? Number of misprints of a book, number of road accidents in a particular locality. These are countable. Therefore, they are discrete. Whereas continuous is if it can assume any value from a given interval. Example, height, weight, sales, profits, and so on. They can have any value in the given interval. Hence, continuous variable. Whereas qualitative characteristics are called attributes. Gender of a baby, nationality of a person, color of a flower, color is inside, color of a flower, etc. They are attributes. They are attributes. So if I can summarize quickly what all we have discussed, data can be broadly divided into
Variable and
attributes. So attributes means qualitative. Variable is quantitative. Under variable we have
discrete and continuous.
Discrete and continuous. Discrete is finite, continuous is infinite.
Infinite.
Clear with this?
Yes, sir.
Yes, sir.
Okay, fine. So this is about the basics about data. Now, what all we want to do in statistics, any analysis we want to do in statistics, we should have the data in hand. So for that, we need to collect the data. Correct? So collection of data, we will divide the entire data set into two types, primary data and secondary data. What are primary data? If I myself is collecting the data for the first time, that is called primary data. The data which are collected for the first time by an investigator or agency, it's called primary. Secondary data, I am not collecting the data. Some agency have already collected the data. I am relying upon the data collected by them. I am borrowing the data collected by them. It is called secondary data. The data are known to be secondary if the data as being already collected are used by different person. So it is collected by Mr. A, used by Mr. B. For Mr. B, it is secondary data. For Mr. A, it is primary
Primary data.
Yes. Now, Coming to collection of data, for secondary data collection, there is no issues because someone has already collected, I'm utilizing it. That's all. Whereas in collecting primary data, there are various types, there are various issues also to be considered. So there are broadly, we can consider 4 types of collecting primary data: interview method, mailed questionnaire method,
Observation method,
questionnaire method.
questionnaire method, correct. Interview method, mail questionnaire method, observation method, and questionnaire method. So we'll quickly understand the difference between these. Some are easy to understand, some there are small differences. So we have 4 different types: interview method, mailed questionnaire method, observation method, and questionnaire method. Interview method, we go and ask questions to the persons, to the victims, and get the information, correct? That is interview method. Under interview, again, we have 3 different types. Either we go personally, so personal interview method,
indirect
Indirect
interview
interview method, telephone interview method,
or telephonic interview.
telephone interview.
Yes, we'll discuss what are those. So under interview method, we go and collect the information. So person visits the place, asks the question, and get the information. That is interview method. Mailed questionnaire method, here we prepare a set of questions. We prepare a set of questions. It can relevant questions. It can be any number of questions, and then we send these questions through mail to the target audience. We send the questions through mail to the target audience. They will give their answers. They will write the answers, send it back to the interviewer, send it back to the person who is requiring the information. That is mailed questionnaire. So no personal touch is involved. Everything happens through mail. That is mailed questionnaire. Observation method, here information is not collected by asking something. It is collected, or information is collected by observing. It can be direct observation or with the help of some instruments. Okay, so here it is more reliable than the other 3 because we are not relying on the information given by the other party, information given by the respondent. In the other 3 methods, we are asking the question, whatever the respondent is answering, I'm recording the data. Whereas here, the observer himself will look into the information, will look into the happenings, and accordingly record the information. Best example is recording the heights of students. There will not ask the height of the student. Instead, we'll make him to stand beside the scale, take the measurement, record the measurement, correct? So that is observation method, observing the height with the help of a device. We'll take the help of a scale there, no problem. Taking the help of a device is allowed. So that is observation method. No information is collected from the respondent. It is directly observed. Then the last one, questionnaire method. What is questionnaire method? Under questionnaire method, similar to mailed questionnaire, we'll have a set of questions. We'll have a questionnaire prepared, but we will not mail it. Instead, we go, or generally what happens, we will appoint agencies, enumerators, whom we call. We'll appoint agents to get the information collected. So what they will do, they will go to the respondents, ask the questions set out by me, then write down the relevant answers, bring it back, bring back the questionnaire to the person who is required of the information. That is questionnaire method. So that is the difference between questionnaire and mail questionnaire. Mail questionnaire, no personal touch is involved. Questionnaire, personal touch is involved, but not of the investigator himself. He'll appoint the agents. Yes, that is the basic differences between these 4 types of collection of primary data. Interview method. So as I said, 3 different types of interviews: personal interview, indirect interview, and telephonic interview. Under personal interview, I go and interview the victim himself, the person from whom I can directly get the information. Okay, so in personal interview method, the investigator meets the respondent directly and collects the required information. So in case of natural calamities, earthquake or cyclone, etc., the persons who want the information, the interviewer, go to that place and take the information, get the interview of the person who was affected by that particular natural calamity, and take the information. That is personal interview, interviewing the person directly. Indirect interview, this is in case of where personal interview is not possible. In that case, we go with indirect interview, wherein the respondent cannot be directly interviewed. The victim, the person who was affected by that particular incident, cannot be directly interviewed. In that case, persons associated with that incident would be interviewed. That is indirect interview. Best example is rail accident. The persons affected, it is impossible for us to interview them. Either they would be dead or they would be seriously injured. Therefore, we cannot interview them directly. Therefore, we go with the eyewitnesses, the persons who have seen that particular accident, interview them and get the information required. That is indirect interview. So the last one is telephone interview. We will not visit the site. Instead, we get the information through telephone. We get the information through telephone, contacting the person over the phone. Okay, so these are the three types of interviews. Personal interview method, investigator meets the respondent directly and collects the required information then and there from them. In case of natural calamity like a super cyclone or earthquake or an epidemic like plague, we may collect the necessary data much more quickly and accurately by applying this method. Quickly because we're directly visiting the person themselves, victim themselves, and accurately because it is directly coming from the person who was affected. Therefore, it is more quick and more accurate. Indirect interview, there are practical issues in reaching the respondent directly. So we take recourse for conducting indirect interview where investigator collects the necessary information from the person associated with the problem. So this word is important. Person associated with the problem. Telephone interview method is quick and rather non-expensive way to collect the primary data. Less effort is involved because not visiting the site. Correct. So non-expensive way to collect the data where relevant information can be gathered by the researcher himself by contacting the interviewee over the phone. Okay. Now, yes, we have discussed about interview method. Yes, there are advantages and disadvantages. There are advantages also, there are disadvantages also. What are the advantages? Wide coverage. We can cover large area, whereas basically this is talking about advantages of telephonic interview. When compared to the other two, we can cover a wide area because we are sitting at one place contacting through telephone. So it is advantages and disadvantages of telephone interview method. Okay, so it has wide coverage but less consistent. The information cannot be relied on completely because we are not directly collecting it. It is through in telephone method. So it is less consistent, but it has very wide coverage. Within a span of limited time, we can cover large number of area. Whereas one of the biggest disadvantages is non-responses is maximum. The persons will be hesitant to give the information over phone. Therefore, non-responses would be maximum. That is the disadvantage of telephone interview when compared to the other two. Clear with this?
Yes, sir.
Yes, sir.
So,
Yes, sir.
Next one, mailed questionnaire. Mailed questionnaire comprises of framing a well-drafted and soundly sequenced questionnaire covering all the important aspects, so complete set of questions, and sending them to the respondent with prepaid stamp after providing the necessary guidelines for filling up the questionnaire. So even instructions would also be provided how to fill up the questionnaire. So here, what is the advantage? Similar to telephone, wide coverage. It is just sending the questionnaire over post. So we can cover large area, wide areas would be covered, but same disadvantage, non-response would be higher, even more higher when compared to telephone, because here the respondent have to make an effort of filling up the questionnaire and sending it back, correct? Therefore, the non-responses would be much more higher. So what are the advantages of mailed questionnaire? Wide area can be covered. Disadvantages, non-responses would be higher. That is mailed questionnaire. Observation method. Data are collected, as in the case of obtaining data on the height and weight of group of students, by direct observation or using instruments. So here, this is the best method because the data collected will be accurate. We are not relying upon the respondent. Therefore, it is the best method, but disadvantages, time consuming, it is laborious, covers only a small area. Huge effort is involved and the information collected will be very small. Small area would be covered. That is the disadvantage. Even though from the accuracy point of view, the data collected will be much more accurate than the others, than the other methods. The disadvantage would be the time required and the efforts involved. Time required and the efforts involved would be very high. Clear with this? That is observation. Last one, questionnaire. Used for larger inquiries from the persons who are surveyed. Enumerators collect the information directly by interviewing the persons having the information. Questions are explained, hence data is collected. So best example this here is census. That is how the information is collected. The persons who are coming to our houses are not the persons who require the information. The information is required by the government. They will appoint the enumerators, correct? And these enumerators will visit the houses, get the required information as specified in the questionnaire and submit it to the government, right? That is the best example of how questionnaire method works. Yes, this is these are the 4 types of collection of primary data. 4 methods of collection of primary data. Then secondary data, there are no specific methods of collection. It is just applying or asking or requesting the particular organization for the data, and they will provide it based on their policies. So sources from where we can get these data, it can be international sources also, it can be a local source also. So it can be anything, international sources like WHO, ILO, IMF, World Bank, etc. Or when we look into the national sources, government sources like Statistical Abstract by Central Statistical Organization, Indian Agricultural Statistics by Ministry of Food and Agriculture. So with various government departments will have their own statistical departments, statistical agencies. So they'll collect the information. From them also we can get the relevant information which acts as secondary data. Then private and quasi-government sources like ISI, ICAR, NCERT, etc. Unpublished sources also. So these 3 are published sources. We can get this information from their website also, or various documents published. But these are unpublished sources. From unpublished sources also we can get the information like various research institutes, researchers, ISRO, IITs, etc. If there are any unpublished information also, upon specific request, we can get the data. Even then, that will be considered as secondary data. Right? These are the sources of secondary data. Now, with that, we have understood what is data and how to collect the data. So, based on how to collect primary data and secondary data, we have broadly divided into primary data, 4 methods of collection, and secondary data, there are only sources from which we can collect the data. Once we have the data, can we directly use it? No, we cannot directly use it because there might be a doubt on the accuracy of the data, the relevance of the data. We have to check whether the data collected is relevant first, correct? So before directly going into the analysis part, we have to first check the relevance or accuracy. That process is called scrutinizing. Scrutiny of data. Since statistical analyses are made based on data itself, it is necessary to check whether the data under consideration are accurate as well as consistent, because accuracy is one part, consistency is the other. Consistency is also important because we are getting the information from various sources. We have to ensure that the information collected from all sources are consistent. It is in the same order, it is in the same format, correct? That helps us in analyzing. Therefore, it has to be accurate also. It has to be consistent also. Now, how do you scrutinize the data? Is there any specific procedure? No. Okay, it is based on intelligence, patience, and experience of the person scrutinizing the information. Now, where can the errors be with regard to accuracy? Errors can be from 3 angles. Errors from the respondent, when the person giving the information himself, if he is giving the wrong information, because of that there can be errors. Or the person who is collecting the information, whom we call enumerator, when the respondent has provided the information, he has given the correct information, but the understanding level of the enumerator, when he is recording that information, his understanding might be different, because of which errors can occur. So based on his understanding, or he has understood it correctly, but while recording, he has recorded the wrong information. So while recording the information also, there can be errors. So errors can be from the respondent point of view, from the enumerator point of view also. But errors, can all errors be identified? No. All errors cannot be identified, but certain errors can be easily identified. How? By inserting cross-check questions in the questionnaire. Okay, so there may be 2 or more series of figures which are related to each other. In the questionnaire, in part A, I'll give an information. I'll give a particular question. Part B, I'll give another question which is totally related to this question in part A. For example, we'll take the example of census itself. Number of children in that family. If they have given it as 3, and in part 2, details, what are they studying or what are they doing, those related details. If there are only information about 2 children, then this information is incomplete. Correct? So this is how we can bring in related questions in the questionnaire to check the consistency, to check the accuracy. This is one of the ways in which we can identify the errors that could have happened in the process of collecting the data. Okay, that is one of the process of scrutinizing. How to do that? By inserting related questions in the other part of the question. Then, if the data for all the series are provided, they will be checked for internal consistency. If there are number of children is specified as 3 and only 2 children's information is given, then it is, we can check for its consistency. It is incomplete. We can ask for the we can ask the enumerator to again get the information. A good statistician can also detect whether returns submitted by some enumerators are exactly of the same type, thereby implying lack of seriousness. So enumerator is has not done his job correctly. What he is doing is filling part A correct properly by asking the information, part B copy paste of the previous person's interview. So in that case, if we look into the part B of all the responses, we find that all are same. So we can identify that the enumerator has not done his job correctly. At that time, what we can do? We can ask him to redo that process again. Go and collect the information again. So the bias of the enumerator also may be reflected by the return submitted by him. This type of error can be rectified by asking the enumerator to collect the data for disputed cases once again. Wherever we have doubt, we can ask the enumerator to collect the information once again. Okay, so this is the process of scrutinizing. Why do we scrutinize? Scrutinize to check the accuracy and
consistency.
correct. Accuracy and consistency. 2 important words. To check for accuracy and consistency of the data. Check for accuracy and consistency of the data. Once we have done the scrutinizing process, once we are sure that the data is accurate and consistent with respect to the analysis that we require, then we can start with the requisite analysis that we require. For that, we require to present the data in a proper manner. Correct. So whatever information that we have would be in 10 different places, 10 different questionnaires. Correct. It would be in unorganized manner. We have to classify it, present it in a proper order so that it is in a organized structural format. That process is called presentation of data. So presentation of data, first is we have to classify the data into 2 to decide on what could be the mode of presentation that we will have. Frequency group, non-frequency group. Under frequency group, we have chronological or temporal or time series. Under the first one. Second one, geographical or spatial series. So data, we would divide it into frequency group, non-frequency. Under frequency, we have one based on time. Second one is based on region, area, based on region. So 2 types of frequency.
Non-frequency group is chronological and temporal.
Yes, sir.
Yes, sir.
I think
Non-frequency
this-
group
I
is
think-
chronological and
Sorry. Yes. This is non-frequency. This is frequency. Right. Okay. So non-frequency group, we have chronological item and geographical item. Correct. Non-frequency of 2 types based on time, based on region, chronological and based on geographical area. Frequency group, we can further divide it into qualitative and quantitative. What is qualitative? What is quantitative? We have already discussed. So qualitative is also called as
Attribute.
attributes. Correct. Qualitative data is also called as attributes. In this particular classification, qualitative data is also called as ordinal data. Quantitative data is also called as cardinal data. Yes. So data can be, for the purpose of presentation, we can divide the data groups into two. What are those two broad categories?
Frequency and non-frequency.
Frequency group
Frequency
and
and
non-frequency
non-frequency.
group. Under frequency group, what are the two?
Quantitative and qualitative.
Yes, qualitative and
Quantitative.
Quantitative.
Under non-frequency,
Chronological, geographical.
And graphical.
right, chronological and geographical. Chronological and geographical. Clear with this?
Yes, sir.
Okay.
Yes, chronological and geographical. Okay, so once we have classified the data, then we'll look into the presentation. How do we present it? Broadly, we have three different types of presentation. One is textual presentation, tabular presentation, and
Diagrammatic.
diagrammatic
Representation.
representation. So textual, tabular, and diagrammatic representation. Textual presentation is pretty simple, writing it in the form of paragraphs, writing an article. That is textual presentation. It comprises of presenting the data with the help of a paragraph or several paragraphs. What is the advantage? Simple.
Simple.
It is very simple.
It
Just convert all the data what you have into words. We get a textual presentation. So it's very simple. However, coming to the disadvantages, it is less attractive. It is dull. Correct? It is dull. It is monotonous. Same approach. And important disadvantages, comparison becomes difficult. Comparison between different observations is not possible, because if I have previous year data in paragraph number 2 and current year data in paragraph number 3, then I have to go back to para 2, come back to para 3 for comparison. So comparison becomes difficult. Okay, so this is the characteristics of textual presentation, just presenting the information in the form of
Paragraph.
Presenting the information in the form of paragraphs, we get textual presentation. Advantages, simple. Disadvantages, it becomes dull, monotonous, and more importantly, comparison becomes difficult. That is the disadvantage. Next one, tabular presentation. The disadvantages of textual is overcome by this tabular presentation. So here what we do, we present the data with the help of table. Present the data with the help of statistical table. It is accurate and best mode of presentation. It is accurate and best mode of presentation. Why it is the best mode? Because it has various utilities. Comparison becomes easier. Further analysis becomes easier. Therefore, tabular presentation or tabulation becomes the, or will be considered as the best mode of presentation. Okay. What are the advantages? One of the disadvantage of textual was comparison. So first advantage is comparison. It facilitates comparison between rows and columns. Even complicated data can also be represented. Any number of rows and columns can be inserted in the tables. So any complicated data can also be presented in the form of table. Third one, third discussion is diagrammatic representation. So for diagrammatic representation, tabular data is a must, is a prerequisite. So tabular data is a prerequisite for diagrammatic representation. Lastly, statistical analysis is not possible without tabulation. So whatever statistical analysis we have, let it be a simple calculation of arithmetic mean. Unless we bring it in a tabular format, it is difficult for us to calculate. Therefore, statistical analysis is not possible without tabulation. These are the four advantages. Comparison, any complicated data can also be presented, and it is a prerequisite for diagrammatic representation. Statistical analysis is possible only in case of tabulation. Okay. Now, how do you construct a table? How do you construct a table? Guidelines for tabulation. First point is it should have a title. The table should have a title and every table should have a table number, serial number. So table number 1, whatever the objective of the table is, that should be part of the title. It should have a title, it should have a serial number. Then table would be divided into 4 parts: caption, box head, stubs, and body. Caption, box head, stubs, and body. This where we bring in the numerical data, it is called
Body.
body of the table. The place where we bring in the column heads are called
Caption.
the captions, that is the column heads, and anything we have in the columns, including the units of measurement, etc., are called
Box head.
is called box head. And the row headings, the row
Stubs.
descriptions are called
Stubs.
stubs. The row headings and row descriptions are called stubs. And at the end, we'll have footnote.
And source node.
Footnote for source.
Yes, source, or if we have any abbreviations, etc., we can bring it in the form of a footnote. And if we are not in a position to bring everything in the body, if we have something which we have to bring to convey a better information, that can be brought in as a head note.
Head note.
Just below the title, head note. Okay, so these are the broad categories that will be involved in case of a table, broad parts of a table. So first we have to start from the table number, compulsory. Table number, title of the table. If you have any additional information, head note, then we'll get then we'll draw the table, rows and columns. The body, which will have the data, the numerical data. Column headings will be called as captions. The entire upper part of the table is called the box head. Then row descriptions are called stubs. Footnote, which will have the source or abbreviations, etc. Clear with this?
Yes, sir.
Sir, what is the difference between caption and box head, sir? Both appear in the same line, sir.
Okay, see, box head includes caption, but caption will not include box head. Okay, so it is something like you will have head. Inside the head we have brain. That doesn't mean that brain is only included inside the head. We have some many things inside, right? Therefore, captions will be called the brain, the main part of the columns. It will have the headings of the columns. So we can call captions as the brain. And entire upper portion, there can be unit of measurement that would be specified just above the column headings. So there will be additional items in the part of the columns. They are called they collectively are called box head.
Okay, sir. Understood, sir. Thank you, sir.
So that is the difference between box head and captions. Okay. Then table should be well balanced in length and width for proper presentation. Then arrangement of data should ensure comparison of the data easily. That is the main objective behind construction of a table. It should be comparable. The comparison should become easy. So accordingly, we should define what should be our columns, what should be our rows, and accordingly construct the table. Arrangement should be in well-balanced sequence. Presentation should be appealing, because one of the disadvantage of text was it is dull. So we have to overcome that disadvantage. So presentation should be appealing. Footnotes having source of data, etc. at the bottom of the table can be brought in. Footnotes. Okay, so whatever we have discussed, it is just brought in here. Different parts of the table, table number, title of the table, caption, which is the column heading, stubs, row headings, body, it contains the numerical data, head notes, something that is not explained in the title, caption, stubs can be explained in the notes on the top of the table, just below the title. Footnotes, source of the data, some exceptions in the data can be given. Table under consideration should be divided into caption, box head, stub, and body. Caption is the upper part of the table describing the column and subcolumns. Box head is the entire upper part of the table, which includes columns and subcolumns, units of measurements, along with the captions. Stubs is the left part of the table providing the description of row. Body is the main part that contains the numerical figures. This is about tabular presentation, tabulation. Okay, so with that, we are done with textual presentation and tabular presentation. Any doubts in this?
No, sir.
Okay,
No.
tabular presentation, very important from the examination point of view. Okay, so there are various discussions. All these are important. Then, diagrammatic representation of data. So even though we consider it as one of the methods of presentation of data, basically it is not an independent method of presentation because it is representation of data. We have already presentation of data, we will represent it in another form. Hence, it is called representation of data. Diagrammatic representation of data, attractive representation of statistical data in the form of charts, diagrams, pictures, etc. Diagrams. So what would be the advantage? It can be understood by anyone. Since it is in the form of diagrams, it can be understood by anyone, educated section or uneducated section of the society, and any hidden trend given in the data can be easily noticed. I'm not saying that tabular representation will not give us the hidden trend. Yes, even it will give us, but even without analyzing further, we can easily notice hidden trend in the diagrammatic representation. How? If we draw a line chart, if there is a sudden increase in one particular financial year of sales, then yes, there is some trend, there is some information that we can look into further analysis in that particular financial year, right? So hidden trend can be easily understood with the help of diagrammatic representation. Coming to disadvantage, when we compare to tabulation, yes, it is less accurate because we'll be plotting it in graphs. So we'll be taking scales, etc., wherein the accuracy would be compromised. So it is less accurate when compared to tabular presentation. That is a disadvantage. Okay. Types of diagrams, we can broadly divide it into line diagram and
Bar diagram.
bar diagram.
Bar diagram.
Line diagram and bar diagram. Line diagram is simple. We have the data in tabular form. Plot that. We'll have x-axis, y-axis, x, let us say years, y production. If you plot them accordingly based on the data given. You plot the dots, then join the points with the help of a straight line. We get line diagram. We get line diagram. So it is used when data vary over time. Plot each pair of the value. That is, for each financial year, we'll have a production, number of units of production. So accordingly, plot those values. Then the plotted values would be joined successively by line segments, resulting in line diagram. That is a basic of line diagram. Okay, that is what we have learned. Then we have two more further discussions in line diagram, which will obviously not asked in the examination. However, some theory questions can be asked from these 2 points. What is that? When we talk about a line diagram, when we talk about year and production in units, we'll generally talk about lesser fluctuation data, 2004 to 6, 2010 to 20, like it will be in the same range. Whereas if we have wide range of fluctuations, in that case, instead of using the line diagram, which would be very difficult to draw, we will use something called logarithmic chart or ratio chart. Log chart or ratio chart. We convert the production units, which we have in tons, into log. So if we call this as y, we convert it into log, then plot this log value in the line chart. That would be our line diagram. When we go with logarithmic chart, when there is
Wide fluctuation.
Wide fluctuations.
wide range of fluctuations. When there is wide range of fluctuations, we go with logarithmic charts. Similarly, there is something called multiple line charts. This is simple. Okay, there is no complications involved in multiple line charts. But the problem here is we'll have two time series data. So I have year, I have production of rice also, production of wheat also. So if I have to bring out both production of rice and wheat in the same line chart, we take the help of multiple line charts. So when we will use multiple line charts are used to represent two or more related time series data expressed in same unit and multiple axis charts. So we use multiple line charts when we have two or more related time series data, time series data. But the problem here is they should be of same units. They should be of same units, expressed in same units. Only then we can go with multiple line charts. If they are of two different units, multiple axis line charts. So simple to remember, multiple line charts, two data, single unit. Multiple axis line charts, two data, multiple units.
Different.
Two data, multiple units. That is about line diagram. Normal line diagram, just plot the values in the chart based on X and Y values. Then join all the plots successively, we get the line diagram. However, if there is wide range of fluctuations, what we will use?
Ratio chart or
Log.
ratio chart.
Log and ratios.
Ratio chart or logarithmic chart. However, in the other scenario, I have more than one time series data, but all the data that I have are of same unit. In that case, what is the chart that I'll use?
Multiple line chart.
Multiple lines.
Correct. Multiple line charts. Then I have more than one time series data with different units of measurement. In that case,
Multiple axis.
Axis line chart.
axis line charts. Clear with this?
Yes, sir.
Yes, fantastic. Next one. Second one, bar diagram. There are two types of bar diagrams: horizontal bar diagram, vertical bar diagram. Bar diagrams are nothing but presentation of data in rectangular bars. Correct. So those bar diagrams can be horizontal like this, or it can be vertical. Horizontal generally is used for qualitative data or data varying over space, that is geographical. So qualitative data or geographical data we use horizontal, quantitative data or time series data we use vertical. Qualitative or data varying over space, geographical we use horizontal, quantitative time series we use vertical bar diagram. How to construct a bar diagram? Simple. We'll have in the same example year and production. 2006, what is the production? 2007, what is the production? Accordingly, based on the values presented in the y-axis, we'll draw bar diagrams. Now, similar to multiple line charts, I have data regarding production of rice and wheat. Production of rice and wheat. I want to present them separately. So in that case, I can do that in bar chart also, that we call group
Multiple
bar
bar
diagram or multiple bar diagram. So how to do that? In the same year, 2004, what is the production of rice? What is the production of wheat? 2005, what is the production of rice? What is the production of wheat? This is how we will present the data. This is called multiple bar diagram. In certain cases, I do not want to disclose them in two different bar. Instead, I want to have a single bar for one financial year. In that bar itself, I want to divide the bar into production of rice and production of wheat. That is called component bar diagram. We are considering both components in the same bar, hence it is called component bar diagram. So 2004, let us say the total production, that is including rice and wheat, is 100 tons, of which, no, we'll take 20 tons, of which 12 is rice, balance 8 is wheat. So this is rice, this is wheat. If we present it in this format, it is called component bar diagram. If we present it besides to each other, they are called multiple bar diagram. This is component bar diagram. Similarly, we have one more, which is called percentage bar diagram. What is percentage bar diagram? Similar to component, but instead of taking it as 20 tons, I'll take the bar as 100%. So I'll take this as 100%. Of this 100%, how much percentage is rice? 12 out of 20, 60%. 12 kgs, 12 tons is rice out of 20. So 60%. So I'll plot 60% as rice, 40% as wheat. That is divided bar chart or percentage bar diagram. Okay, are used to compare different components of a variable in relation to a component to a whole. So these are three different types of bar diagrams. First is a simple bar diagram, wherein we have horizontal and vertical, depending upon the data that we are using. Then multiple bar diagram, component bar diagram, percentage bar diagram. Multiple component and percentage. Clear with this? Yes.
Yes, sir.
Okay. For this situation, we can also have pie chart. So instead of converting it to 100 percentage bar diagram, I'll convert it into 360 degrees. I'll convert all the given data into degrees, then draw a circle, divide the circle based on the degrees that we have got, we get pie chart. Right? Okay. So that is diagrammatic representation. Clear with this? Yes. And
Yes,
the
sir.
next is frequency distribution. The next part of the chapter, frequency distribution. What is frequency distribution? Distribution of frequency data. Frequency data means it represents the number of times a particular variable, a particular characteristic is repeating.
Frequency.
Yes, the number of times it is repeating. Frequency data occurs in case of statistical classification of data related to variables or attributes, tabular representation of statistical data relating to measurable characteristics of the values is considered as frequency distribution. If we have attributes, first we have to convert it into quantitative, then only we can have frequency distribution of the same. Then figure corresponding to a particular class signifying the number of times a particular class occurs is called frequency. Number of times it is occurring, that is called frequency. Frequency distribution is a tabular format. So it is a statistical table which distributes total frequency to number of classes. So we'll have different classes, class intervals, correct, 5 to 10, 10 to 15, 15 to 20, etc. We'll have total number of observation. Distributing that observation into frequencies of that class interval is called frequency distribution. Arranges the observations in terms of number of groups. So there are two types of distributions depending upon the data. We have two types of data, discrete variable and continuous variable, two types of variables, correct? Similarly, for discrete variable, we go with the discrete frequency distribution, continuous variable, continuous frequency or grouped frequency distribution. Discrete or ungrouped or simple frequency, tabulation done in respect of discrete random variable. Group frequency distribution, tabulation done in respect of continuous variable. It is done against group of values. Okay, what is the steps in frequency distribution? If it is a discrete, very simple, correct? I bring out all the values in part of the data, then correspondingly calculate the frequencies. Whereas if it is continuous, the issue comes in selecting the number of, choosing the number of class intervals. So for that, what we have to do, what is the first step in case of construction of continuous frequency distribution? Calculating the
Range.
range. The maximum value given in the data minus minimum value part of the data, we get the range. Then decide on the size of the class interval. So once we have the size of the class interval and the range, we can easily calculate the number of class intervals. Number of class intervals would be
Range divided by class.
range divided by the size of the class intervals. Range divided by the size of the class intervals. We get number of class intervals, then bring them in the form of a table, write down all the class intervals that we have to bring in. Then we will bring out the frequencies in the form of tally marks. Correct. We'll have the tally marks. Based on the number of occurrence, we'll bring out the tally marks. Then once all the data are completed, then we'll total, which would get the frequency 3, 5, 6. So we get the total frequency. So this is how we'll construct frequency distribution in case of continuous variable. So steps in frequency distribution: find the largest and smallest observation and obtain the difference. Find the number of class intervals. Number of class intervals into class intervals equals range, size of the class interval. Present the class interval in a table called frequency distribution table. Count the tally marks. Present these numbers in the next column known as frequency column. Check whether the total of all these class frequency tally with the total number of observations for our cross reference. Okay, so this is how we construct frequency distribution. Now comes the next part of the discussion, various terminologies that we have to discuss in frequency distribution. First one is class limit. What is class limit?
Maximum and minimum.
Yes, maximum and minimum value of the class intervals. The minimum and maximum value the class interval may contain. So minimum value is called lower class limit. Maximum value is called upper class limit. So if I have the class limit or class interval of 0 to 5, what would be the lower class limit? 0. Upper class limit?
5.
Correct. Upper class limit 5. Then class boundary, similar to class limit, but there is a small difference. Class boundary is the actual class limit of the class interval. Now we can divide the frequency distributions into two types. having mutually exclusive class intervals, having mutually inclusive class intervals. So for mutually exclusive class intervals, what are the examples? 0 to 5, then we'll have
5
to 10.
5 to 10, correct. 5 to 10, 10 to 15, 15 to 20, etc. Mutually inclusive, 0 to 5,
6 to
6 to
10.
6 to 10, 11 to
11 to
15,
15.
16 to 20, etc. Correct. Mutually inclusive. In case of mutually exclusive, no confusion, class limit itself will be the class interval. Sorry, class limit itself will be the class boundary. Whereas in case of mutually inclusive, there is something between 5 and 6. There is something between 10 and 11. Therefore, we have to calculate that value, which would be the actual limit for this class interval. That is called class boundary. How to calculate the class boundary? Very simple. Consider the upper class limit of this class interval, lower class limit of the next class interval. Take the difference of it. We get that is called D. Correct. Then if you want lower class boundary, lower class limit minus D divided by 2. You want upper class boundary, upper class limit plus divided by 2. So if I have 6 to 10, 10, 11 to 15 as the class intervals, then for this class interval, what would be the lower class boundary?
5.5.
5.5.
Because D is 11 minus 10, 1. 1 divided by 2 is 0.5. 6 minus 0.5 is 5.5. What would be the upper class boundary?
10.5.
Yes, D is 1. So 1 by 2 is 0.5. Upper class limit is 10. 10 plus 0.5 is 10.5. So the lower class boundary is 5.5. Upper class boundary is 10.5. Even though the lower class limit is 6 and upper class limit is 10. That is the difference between class limit and class boundaries. Clear with that difference?
Yes, sir.
Yes.
Sir.
Next is midpoint, mid value or class mark. So simple. So this is the point at which the class limit or class boundaries can be divided by 2. So how do you calculate the mid value? Either you consider class limit or you consider class boundary, you'll get the same answer. So LCL plus UCL by 2 or LCB plus UCB by 2. You take the average, that would be the midpoint. Length and width or class size of a class interval, UCB minus LCB. It is not class limits. You have to consider class boundary here. For midpoint or mid value, there is no difference. You consider class limit or class boundary, that doesn't make any difference. But for calculation of length of the class interval, you have to consider class boundaries itself, because 6 to 10 actual limit is 5.5 to 10.5. So if I consider this difference size is 4, but actually it is 5. Correct. So we have to consider class boundaries itself for the purpose of calculating size of the class interval. Cumulative frequency. So we have learnt frequencies, so class intervals corresponding frequencies. If I go on adding the frequencies one after the other, we get cumulative frequency. So if we start from 0, if we start from the ascending order, that is called less than cumulative frequency. If it is other way around, if we start from the highest number, then that is
More than
more than cumulative frequency. What does less than cumulative frequency denote? It denotes that the total number of frequencies below my upper class boundary of the class interval is so much. So let us say, we'll take an example if you are getting confused. 0 to 5, 5 to 10, 10 to 15, 15 to 20. Frequencies 5, 12, 6 and 8. So 5, 17, 23 and 31, right? 23 and 31, this becomes less than cumulative frequency. If I consider 10 to 15, 23, it means that below 15, I have 23 values. Less than 15, what is the number of value? 23. Similarly, more than cumulative frequency, it is 31, 31 minus 5, 26, 26 minus 12, 14, 14 minus 6, 8. So more than cumulative frequency, it means that more than 10, I have 14 values. More than the lower class boundary of the class interval, more than 10, I have 14 values. That is less than cumulative frequency and more than cumulative frequency. Frequency density. Okay, I could have used the same. No. Okay, frequency density. So we would have learned something called population density. Population density means for that particular area in square meters, what is the total number of population that we have? Population divided by area, we get population density. Similarly, for this class interval with class width of 5, what is the frequency that you have? 5 divided by 5. Frequency density is 1. 12 divided by 5, frequency density is 2.4. 6 divided by 5, 1.2. 8 divided by 5. That is frequency density. So we are comparing the frequency with the width of that class interval. That is frequency density. Similarly, if I compare the frequency with the total frequency of this class interval to the total frequency, we get
Relative
Relative
frequency.
we get relative frequency.
frequency.
So 5 divided by total is 31. 5 divided by 31 would be the relative frequency. Basically, it's the proportion. Calculating the proportion. That is relative frequency. 12 divided by 31. 6 divided by 31. If we present that in percentages, it is called
Percentage frequency.
percentage frequency. Exactly. So frequency density is defined as ratio of the frequency of that class interval to corresponding class length. The frequency density, okay, that is an example. If we have 3 for class width 5, frequency density is 3 by 5.6. 4 for a class width of 5, 4 divided by 5.8. Relative frequency and percentage frequency of a class interval. Relative frequency is defined as ratio of class frequency to the total frequency. Percentage is expressing the relative frequency in the form of percentage. Clear with this? So these are the terminologies that we are learned. Class limit, class boundary, midpoint, class length, cumulative frequency, frequency density, relative frequency, and percentage frequency. Then we will move on to the last part of this chapter, graphical representation. Graphical representation, we discussed 4 different ways of representing it. Histogram or area diagram, frequency polygon, then ogives, and last one, frequency curve. Correct. So if we have understood bar diagram and line chart thoroughly, these are pretty simple. Histogram or area diagram, when we have continuous frequency distribution, we go with histogram or area diagram, wherein it is nothing but bar diagrams itself, but each class interval would be adjacent to each other. Unlike bar diagram, we'll have space in between. That is the difference between bar diagram and area diagram. This is very convenient way to represent a frequency distribution. It helps us to get an idea of the frequency curve of the variable under study. Then comparison among the frequencies is possible because it is in the form of a diagram. So comparison becomes easy. Then to draw histogram, we will not consider class limits, we will consider class boundaries. This part is important. This is important from the examination. Class limits are converted to class boundaries and series of adjacent rectangles are brought in one against each other. Okay. Now, using histogram, I can find out one of the measures of central tendency. What is that?
Mode.
Frequency polygon.
Mode. The
Mode.
frequency polygon is again part of a graphical representation. Measures of central tendency, mode. How to calculate? First, identify the highest. Correct. The highest bar we'll consider, highest rectangle we'll consider that. Then from the left top corner to the next intersection point of the next bar diagram, right top to the intersection point of the previous bar diagram, these two lines intersect at one point, draw a straight line. This is mode. So mode can be calculated with the help of histogram. And to calculate histogram, we'll convert class limits into
Class boundary.
boundaries. That is histogram. Next one, frequency polygon. This is similar to line diagram. Okay, so we plot the points, we plot the points as given in the data, then join all the points, we get line diagram. But one extra point here is, an extension at the extremes. Okay, so the extension at the extremes so that it joins the x-axis. Plotted points are joined successively by line segments. Figure so drawn is given a shape of a polygon by joining the two extreme ends to two additional points. That is frequency polygon. Here, one point that we have to keep in mind is, and in line diagram, it was simple because the data was discrete. But here we have continuous data. So I have to plot one single point. So I'll have continuous data. So what to do?
Midpoint.
Yes,
Mid, consider midpoint.
midpoint. We'll calculate the midpoint, and against the midpoint, we'll plot the values. Clear with this? So in area diagram, what we have to keep in mind? Class boundary is the point that we have to keep in mind. Frequency polygon, midpoint is the point that we have to keep in mind. Clear with this?
Yes, sir.
Yes. Then ogives, or it's also called as cumulative frequency graph, because instead of plotting frequencies, unlike histogram and frequency polygon, we plot cumulative frequencies. Right? So since we have two types of cumulative frequencies, less than cumulative frequency and more than cumulative frequency, we have two types of ogives: less than cumulative frequency ogive, more than cumulative frequency ogive. Okay, by plotting cumulative frequencies against the respective class boundary, we get ogives. As such, there are two ogives: less than type ogive, obtaining by taking less than cumulative frequency on the vertical axis, more than type ogive by plotting more than type cumulative frequency on the vertical axis. Thereafter, joining the plot, same line diagram what we were doing. Ogives, using ogives, we can calculate quartiles. Easily, we can calculate median. How do we calculate median? We have more than cumulative ogive and less than cumulative ogive. How do I calculate median?
Point of intersection.
Point of intersection.
Intersection of less than and more than. Draw a line. This is median. So ogives may be considered for obtaining quartiles graphically if perpendicular is drawn from the point of intersection of the two ogives on the horizontal axis. X value gives us the value of median, second or middle quartile. So it can also be used for making short-term projections. Ogives can also be used for making short-term projections. The last part is frequency curve. Frequency curve, it is smooth curve for which total area would be taken as unity. So I will have to plot the frequencies, then draw a line, curve, draw the diagram. You'll get a curve. Instead of straight lines, I'll be drawing curves. Okay, here it will not be the frequency that I'll be plotting. I'll be plotting the frequency, relative frequency. I'll be plotting relative frequency. Okay, I think I have confused. In line diagram, we'll be plotting the frequencies. Hence, we get the line diagram something like this. But in frequency curve, we are not plotting the frequencies. We are plotting relative frequency. Therefore, we'll get the curve something like this, or something like this, or something like this, depending upon the distribution of the frequency. Why do we get this? Because we calculate relative frequency. What is relative frequency? The proportion. Right? Calculate the relative frequency, plot them in the graph and draw the curve according to the plottings. We get the frequency curve. Why we calculate relative frequency? Because we consider the total area as unity 1. Therefore, we have to calculate relative frequency for the purpose of frequency curve. Alternatively, it can also be obtained by drawing smooth and freehand curve through the midpoints of the upper side of the rectangles, forming the histogram. So histogram, midpoint on the upper side, you draw a freehand curve through those midpoints, you get frequency curve. Alternatively, there are 4 types of frequency curve: bell-shaped curve, something like this, which is similar to normal frequency curve, the normal curve, right? So here what happens? Initially and at the end, basically at the extremes, the values would be lower, the frequency would be lower, and the frequency would peak at the middle. So such type of distributions will have bell-shaped frequency curve. Most commonly used curve is bell-shaped, whereas U-shaped curve is reverse. At the frequency, at the extremes, the frequency would be higher. In the middle, the frequency would be lower. That is U-shaped curve. J-shaped curve is, it starts with a lower value, minimum frequency. So at the starting, it has minimum frequency. At the end, it has maximum frequency. That is J-shaped curve. Mixed curve can have any combination of any of the above. So 4 types of frequency curves: bell-shaped curve, U-shaped curve, J-shaped curve, and mixed curve. Basically, 4 different categories of graphical representation: histogram, then frequency, polygon, ogives. Under ogives, we have 2, less than and more than cumulative type ogives. Then we have frequency curve under that bell-shaped, U-shaped, J-shaped, and
Mixed curve.
clear with this?
Yes, sir.
Yes, with that, we are done with the first chapter. The next chapter is measures of central tendency and measures of dispersion. Measures of central tendency, first two different parts of the chapter. First part is measures of central tendency. What is the central tendency? Central tendency is the tendency of the observations to cluster around the central value. Correct? Defined as the tendency of the given set of observations to cluster around the central value. That central value is called average. That central value is called average. Measures of central tendency facilitates in comparing different distributions. So I have two different set of distributions. I have to compare. I'll calculate the average and compare the distribution. So it helps us in comparing the distributions. The measures that we use to calculate that central value, that average, is called measures of central tendency. So criteria for having ideal measure of central tendency, these are the characteristics that a central tendency should have. A measure of central tendency, it should be properly and unambiguously defined, no confusion. Then it should be easy to comprehend, simple to compute, based on all the observations. Then should have certain desirable mathematical properties. Further analysis should be possible. It should be least affected by the presence of extreme observations. So it is very difficult to get a measure of central tendency satisfying all. So we go with those measures of central tendency satisfying the maximum number of requisites. Okay, so these are the 6 requirements, 6 criteria. Based on that, we have 5 different measures of central tendencies. First one is arithmetic mean. Simple. What is arithmetic mean? Total of all the observation divided by number of observations. Correct. X bar is summation x by n, total of observation by n. Whereas if it is grouped, if you have frequency, fx by n. So if I have x, if I have f, what I have to do? First I have to calculate fx, total the fx column, summation fx, total the frequency column, summation f itself will be n. So summation fx by n, we get the arithmetic mean. Correct? Yes. Okay. Now we have one alternative formula. If the classification is uniform, that is the class length is uniform, the class intervals, the class length are uniform, then we can alternatively calculate arithmetic mean using this formula, a plus summation fd into c by n. So what do we do here? I have class intervals, I have frequencies. Normally what I'll do, I'll calculate x, the midpoint, fx, summation fx by n, we get the arithmetic mean. But here, instead of taking fx, I'll select one value as assumed mean. That means that value can be any value. It need not be one of the x values also. Okay. So we'll select one value called a, which is the assumed mean. I'm presuming it to be the mean. Then I'll calculate x minus a divided by c. C is length of the class interval. So with that, I get something called d. How do I get d? X minus a by c. I get d. I have d. I'll multiply f and d. Instead of f and x, I'll consider f and d. Total this f and d. Okay. Then how do you calculate mean normally? Summation f x by n. So it should be summation fd by n only. But to calculate d, I have divided it with class interval, class length. So multiply it with class length. Then you have subtracted a. So add a. That's all. We get the formula for calculating arithmetic mean, alternative formula. A plus summation fd into c by n, d is x minus a by c, where c is class length, a is the assumed mean. That is the alternative way of calculating. Okay. Next comes, these are simple. Next comes the important part of this discussion, properties. Very important. If all the observations are constant, say k, arithmetic mean is also constant. If I have 3 values, 15, 15, 15, what would be the arithmetic mean of these 3?
15.
15. So if all the values are same constant, then the arithmetic mean will also be the constant. The algebraic sum of deviation of set of observation from their arithmetic mean is 0. This is important. You might get confused. In median, we have a different discussion. So how do you calculate? You have x, you have f, you would have calculated fx and calculated x bar. Now, if you can calculate the deviation x minus x bar for each values, get the total of it, you'll get 0. The sum of deviations of set of observation from arithmetic mean is 0. So if it is of classified data, multiply f into x minus x bar, that would be 0. So for x minus x bar, summation x minus x bar would be 0, or summation f into x minus x bar would be 0. Clear with this?
Yes, sir.
Yes.
Yes, sir.
Okay, fine. That is the first one. Second property, sorry. Third property, arithmetic mean is affected due to change of origin, change of scale. Very important discussion. We have this here also, measures of dispersion also, then subsequently. Correct? So it is affected, correlation, regression, there also we have this discussion. So arithmetic mean, or rather if we want to remember it easily, all measures of central tendency gets affected by change of origin, change of scale.
Okay.
Since they get affected by change of origin and change of scale, if I want to convert x to y in this order, y is equal to a plus bx, then what would be x bar? A plus b into x bar. Sorry, y bar. What would be y bar? Y bar is a plus b into x bar. So if y is equal to a plus bx, y bar will be equal to a plus b. So here what is b? Change in scale or origin? Scale. Multiplication, division, scale. A is origin plus or minus, correct? Change in scale or change in origin. So our measures of central tendency gets affected by change in scale as well as change in
Origin.
Correct. Now combined mean. So if I have two sets, n1 x1 bar for one set, n2 number of observation, x2 bar being the arithmetic mean, how do I calculate the combined mean? n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Simple combined mean. Same if I have more than two groups. If I have three groups, it would be n3 x3 bar divided by n3. This is how I have to calculate for three groups. So if it is more than two groups, it would be summation ni xi bar. I depends on the number of sets we have divided by summation ni. Summation ni. This is about arithmetic mean. Any doubts in this?
No, sir.
Can I move on to
No,
the next one? Median.
Yes, sir.
Yes. Median, simple. What is median? It is a middlemost value. Middlemost value when the observations are arranged either in ascending or descending order of magnitude. So arrange it in ascending or descending order, middlemost value will be the median. If I have two values as middlemost value, then I'll calculate the average of it as the median. It is called positional average because they're positioning the value as the middlemost value. So it's positional average. Value of a median is dependent on position of a given set of observations for which median is wanted. Then, in case of grouped frequency distribution, in case of ungrouped distribution, simple to calculate median, ascending or descending order, middlemost value. For grouped frequency distribution, we have this formula. L1 plus n by 2 minus nl divided by nu minus nl into c. For that, first we have to calculate the median class. How to identify the median class?
N by 2.
N by 2.
N by 2. N by 2, you will have the cumulative frequency, where the cumulative frequency, in which range of cumulative frequency that particular n by 2 value falls, that would be the median class.
Median class.
Yes. Once you identify the median class, L1 is the lower class
Lower
boundary
class.
Lower class boundary.
of that median class. N by 2 we will already have. NL is the cumulative frequency of
Previous.
Pre-median class.
previous median class. Correct. That is pre-median class. Less than cumulative frequency corresponding to pre-median class. NL is pre-median class. NU is
Cumulative frequency of median class.
correct median. Correct median class. That is the median class interval. What is the cumulative frequency? Minus cumulative frequency of pre-median class into C is the length of the class, median class. Length of the class interval of the median class. With this, we get the median. That is how we have to calculate median. Properties, simple, same properties. So if x and y are two variables, y is equal to a plus b, change of origin, change of scale. So y median is equal to a plus b into x median. Now, in arithmetic mean, we have discussed summation x minus x bar is 0. That is, sum of deviations from the arithmetic mean would be 0. Here, if we take the deviation, the absolute deviations, not normal deviation, absolute deviation, then sum of the absolute deviations, it would be minimum when the deviation are taken from median. The absolute deviations would be minimum when the deviations are taken from median. So we have x, we have f. Okay, let us say we have only x. I have x, I have x bar also, I have median also. I have calculated x minus x bar. This total will always be 0. Now, instead of x minus x bar, what I'm doing, instead of x minus x bar, I'm calculating modulus x minus x bar. What is modulus? Absolute. So, if x bar is 6, here I have 2, 3, 4, 5, 6. Okay, x bar will be 4. If x bar is 4, 2, 3, 4, 5, 6. So 2 minus 4, even though it is minus 2, I have to consider it as 2 because I'm taking absolute deviation. 3 minus 4, what would be the absolute deviation?
1.
1. 4 minus 4?
0.
5 minus 4 will be 1 and 2.
One,
So I have to take the absolute deviation. This absolute deviation would be minimum when the deviation is taken from
Median.
median.
yes, when the deviation is taken from median. Correct. Then partition values, quartiles, fractals, extension of median. What they do, they divide the set of observation into equal parts. If we have 2 equal parts, we call it as median. If we have 4 equal parts, we call it as
Quartiles.
Quartile.
how many quartiles we have?
3.
3.
quartiles.
If we divide it into 10 equal parts, we call it
Deciles.
how many
Deciles.
deciles?
9 deciles.
9 deciles.
Correct. 100 equal parts?
Percentile.
Percentile.
99
99.
percentiles. Correct. How do you calculate quartiles or any of the percentile values? Same formula, QL1 plus NP minus NL divided by NU minus NL into C. What is the difference? NP. There we had N by 2. Correct. Here it is NP. What is NP?
P theta 1/4.
Okay. Yes. If it is quartiles, yes. Correct. N plus 1 by 4.
4.
So we get that is NP. If it is deciles, it is N plus 1 by
10.
10. It is percentiles, it is
100.
100. Correct. That is how we get NP value. Based on that NP value, we'll select the quartile class, decile class, or percentile class based on the cumulative frequency calculation. Same as median discussion. Then all other values remain the same. Okay. Now, this is formula. We have one more way of finding out quartiles with the help of ogives. We had discussed when we discussed about ogives. We can calculate median. Similarly, other quartiles also can be calculated. To find a particular quartile, we draw a line parallel to the horizontal axis through the point NP. We draw perpendicular from the point of intersection of this parallel line and ogive. X value of this perpendicular line gives us the value of quartile. Okay. So if we consider less than ogive, we have NP value. That NP value will be on the y-axis. You draw a parallel line like this. It will intersect at some point in ogive. You draw a perpendicular line. This will be that required value, quartile, percentile, or decile. Okay, that is how we calculate quartiles using ogives. Yes, that is about median. Can we move on to the next discussion?
Yes.
Yes, next one is mode. Mode. So what is mode? The value which appears maximum number of times, which occurs maximum number of times, highest frequency. Correct. The value which has maximum concentration of observation around it. Okay. So since this is maximum number of times, a particular distribution can have more than 2 modes also, more than 1 mode also. Right? So they are called multimodal distributions. If it has 2 modes, we call it bimodal distribution. If it has 1, we call it unimodal distribution. Correct. How to calculate mode in case of grouped frequency? In case of ungrouped, it is simple. Calculate the value having highest frequency. In case of grouped frequency, first we have to identify modal class. How to identify modal class?
Highest frequency.
Higher.
Class interval having the highest frequency. That would be the modal class. Once you identify modal class, you will have all this value. L1 same LCB of the modal class. F0 is frequency of
Model class.
modal class. F1 is frequency of
Previous.
Model
Previous.
class.
next. F1 next class.
Next class, sir.
Post modal class. F0 F minus 1 is
Previous.
previous modal, pre-modal class, frequency of pre-modal. Here, remember, in median we use cumulative frequency. Here we use frequency. Cumulative frequency will not be used here. Then into C will remain the same class interval. So the formula will be L1 plus F0 minus F1 divided by 2F0 minus F minus 1 minus F1 into C. Okay. Then the same property of change of scale and change of origin. If y is equal to a plus bx, y mod is equal to a plus b into x mod. That would still apply. This is mode.
Isn't it F0 minus F minus 1?
Minus 1. Sir. F minus 1. F0 minus F.
Numerator.
F minus 1, so
Okay,
pre-modal.
F0 minus F minus 1. Yeah, F0 minus F minus 1 pre-modal frequency. Correct. F0 minus F minus 1. So I'll repeat the formula. L1 plus F0 minus F minus 1 divided by 2F0 minus F minus 1 minus F1 into C. Correct. Yes, that is how we calculate mode. Okay. Now, empirical relationship between mean, median, and mode. Mean minus mode is 3 into mean minus median. It is sufficient for us if we remember this. Mode is equal to 3 median minus 2
mean.
Two more.
mean. So when we talk about mean, median, and mode, we start with mean, then we go to median, then we go to mode. Correct? Now come in the reverse order. Mode is equal to 3 median minus 2 mean.
Mean.
Mode, median, and mean. Easy to remember. Mode is equal to 3 median minus 2 mean. This is about mean, median, and mode. Next one we have is
Geometric.
yeah, geometric mean. What is geometric mean? Geometric mean is, the definition is nth root of the product of the observation. If I have 3 observations, cube root of those observations, the product of those observations, 2, 3, and 5. So cube root of 2 into 3 into 5, I get the geometric mean. So the formula will be geometric mean is x1 into x2 into x3 into xn, the product into 1 divided by n, to the power of 1 divided by n. This is nth root, to the power of n divided by n. If I have frequency distribution, furthermore, it is not just multiplying the observations, take the power of that frequency. x1 to the power of f1 into x2 to the power of f2 into x3 to the power of f3. So if I have x values as 2, 3, 4, frequency values as 3, 4, 5, then cube root of, sorry, not cube root, 1 divided by n, total of the frequency, 9, 12, 12th root of 2 cube into 3 to the power of 4 into 4 to the power of 5. That is how we have to calculate geometric mean. So nth root of product of the observation. So what are the properties of the geometric mean? These properties are very important. Okay, I have calculated geometric mean. If I apply log on this geometric mean, logarithm of this geometric mean would be arithmetic mean of the logarithm of the observations. So what would be the logarithm of the observations? I have calculated logarithm geometric mean of 2, 3, and 5. Okay, then I'm applying log on this geometric mean. This would be equal to, you calculate logarithm of 2, logarithm of 3, logarithm of 5, arithmetic mean divided by 3. Arithmetic mean of logarithm of the observations. So logarithm of geometric mean for a set of observation is arithmetic mean of logarithm of the observations. Arithmetic mean of logarithm of the observations, that is summation divided by total. Log G is equal to 1 divided by R into summation log X. This is nothing but summation log X by R. R can be replaced by N, the number of observations. Second one, if all the observations are constant, the geometric mean is also K. So if all the observations are 2, 2, and 2, if I want to calculate geometric mean, cube root of 2 into 2 into 2, 2 into 2 into 2, cube root is 2. Correct. Therefore, geometric mean of a constant would also be constant itself. Now, now I know Z is equal to XY. Okay, so if I want to I know what is geometric mean of X. I know what is geometric mean of Y. If I want to calculate geometric mean of Z, I need not calculate the geometric mean for these observations. Instead, I will multiply these two. Geometric mean of X into geometric mean of Y would be geometric mean of Z. Geometric mean of product of two variables, if the product of their geometric means is the product of their geometric means. If Z is equal to XY, geometric mean of Z is geometric mean of X into geometric mean of Y. Clear with this? Last one. Similarly, if Z is X divided by Y, I know geometric mean of X, I know geometric mean of Y. To calculate geometric mean of Z, geometric mean of X divided by geometric mean of Y. Clear? Now, what is the disadvantage? It is most difficult to calculate if there are more values because of the roots, square roots or cube roots, accordingly, the number of roots involved in the frequency, in the data, in the calculation. Next one is harmonic mean. Simple definition. It says reciprocal of arithmetic mean of reciprocal of the observation. So first you have to calculate the observation X. You want the reciprocal 1 by X. Correct? You have to calculate arithmetic mean. How to calculate arithmetic mean? Summation 1 by X by N of all this. Then you want reciprocal of this arithmetic mean, which is N divided by summation 1 by X. So N divided by summation 1 by X is the harmonic mean. For grouped frequency distribution, it is capital N divided by summation F by X. Instead of 1, it would be summation F by X. Harmonic mean. Properties same. If all the observations are constant, harmonic mean is also the same. K. Combined harmonic mean. How to calculate? Combined harmonic mean, it is N1 plus N2 because it is reciprocal divided by N1 divided by H1 plus N2 divided by H2. In arithmetic mean, we were doing N1 X1 bar plus N2 X2 bar divided by N1 plus N2. This N1 plus N2 would be in the numerator here. N1 X1 bar, this is reciprocal. So you do N1 divided by X1 divided by H1. So N1 plus N2 divided by N1 divided by H1 plus N2 divided by H2, we get combined harmonic mean. Clear with this? Then next one. Relation between arithmetic mean, geometric mean, and harmonic mean. Always arithmetic mean is greater than or equal to geometric mean, greater than or equal to harmonic mean. Why do we use equal to? Because at one point AM is equal to GM is equal to HM when all the observations are equal. When all the observations are equal, AM is equal to GM is equal to HM. Else AM would be greater than GM, would be greater than HM. With that, we get one more relation. AH is equal to G square, very important from the examination point of view. You can get problems from this particular relation. AH is equal to G square. Arithmetic mean into harmonic mean is square of geometric mean. Small discussion on weighted average. Basically, weighted average is nothing but frequency. Adding frequencies to that value. It is used when observations have a hierarchical order of importance. Weighted arithmetic mean is summation WX divided by summation W, which is nothing but Fx by N. Okay, then geometric mean is anti-log of summation W log X divided by summation W. Harmonic mean is summation W divided by summation W by X. That is summation N divided by summation
F by X.
Yes, F by X. N divided by summation F by X. Okay. Okay. When will you use arithmetic mean, geometric mean, and harmonic mean? Very important. Arithmetic mean is the most commonly used average. Arithmetic mean is most commonly used average. Geometric mean is used for calculating rates, ratios, percentages, etc. Harmonic mean, average of speed. We had solved one problem, MTP problem, if you remember. Correct. Average of speed for just 20 kilometer distance, for going 30 kilometers per hour, coming 40 kilometers per hour. What would be the average? Correct. We had calculated that harmonic mean. So in case of speed, average of speed, we go with harmonic mean. Any ratio, percentages, etc., we go with geometric mean. Else, commonly used is arithmetic mean. Okay. Comparing these three, the best measure of central tendency is arithmetic mean because of its ease of computation, ease of comprehension. Okay. It is rigidly defined, no ambiguity, no confusion. Rigidly defined. It is based on all the observations. and easy to comprehend, simple to calculate, and it is amenable to mathematical properties. If you remember those 6 criteria for ideal measures of central tendency, it satisfies 5. The only one criteria it doesn't satisfy is affected by sampling fluctuations. Extreme values affected by sampling fluctuations, etc. It gets affected. That is one of the disadvantages of arithmetic mean. And one more disadvantage is it cannot be calculated for open-end classification. So I have less than 100, 100 to 200, 200 to 300, more than 300. In this case, can I calculate arithmetic mean? I cannot calculate x for this and this. Therefore, open-end classification, I cannot calculate arithmetic mean. Then, median. Median is also rigidly defined. No ambiguity there. It is easy to comprehend and compute also. But the disadvantage is not based on all the values. We'll select just middlemost value. The other values are not at all considered. Correct? We are least bothered about the extreme values. So it is not based on all the observation, does not allow itself to mathematical treatment. That is again one more disadvantage, but it is not much affected by sampling fluctuation, and it is the most appropriate measure for open-end classification. I can easily calculate median in case of open-end classification. So for open-end classification, the most appropriate measure is median. In examination, they need not ask a straightforward question. They can give you a class interval. They can give you a frequency or open-end class interval. And the question is calculate the most appropriate measure of central tendency. At that time, we have to calculate median. Clear? Yeah. Then mode. Although mode is the most popular measure of central tendency, there are cases where mode remains undefined. What if there is no maximum repetition frequency, highest frequency related value in the frequency distribution? No mode, correct? So mode remains undefined. That is one of the disadvantage, and it has no mathematical property. And mode is also affected by sampling fluctuations. Then geometric mean, harmonic mean possess some mathematical properties. We can have some analysis done. They are rigidly defined and they are based on all the observations, but the disadvantage there is difficult to comprehend and compute. That is the main disadvantage. Apart from that, they're the best measures of central tendency, but the disadvantage is difficult to comprehend and compute and have limited applications for computation of average rates, ratios, etc. Clear with this? Yes. With that, we are done with measures of central tendency. Next, the last part of this chapter, measures of dispersion. Measure of central tendency is the tendency of the values to cluster around the central value. Measure of dispersion is the amount of deviation of the values from that central value. Amount of deviation of that values from the central value. Second important characteristic of a distribution is given by dispersion. Two distributions can have same central tendency, can have same average, can have same arithmetic mean, but their measure of dispersion could be different because they differ with respect to their scatterness. Correct? Dispersion is the amount of deviation from an appropriate measure of central tendency. Classification of dispersion broadly into two: absolute measures, relative measure. Absolute measure, range, mean deviation, standard deviation, quartile deviation. Relative, coefficient of them: coefficient of range, coefficient of mean deviation, coefficient of standard deviation, or coefficient of variation, coefficient of quartile deviation. Now, what is the difference between absolute measure and relative measure? Under absolute measure, we will retain the units as it is. So, absolute measures are dependent on unit of the variable. This is unit free. Relative measure. Absolute measures cannot be compared. So, absolute measure of dispersion of two distributions cannot be compared if there are two different units. Whereas relative measures, since they are unit free, they can be compared. Absolute measures are easy to compute and comprehend. Relative further steps are there, so difficult to compute and comprehend. That is the difference between absolute and relative. Characteristics, same characteristics. It should be properly defined, easy to comprehend, simple to compute, based on all the observations, unaffected by sample, then sampling fluctuations, and amenable to some desirable mathematical treatment. Okay, these are the desirable characteristics of an ideal measure of dispersion. So with that, we'll start with the first dispersion, range. What is range? Difference between largest and smallest value of the observation. Difference between largest and smallest. In frequency distribution construction, we discussed the first step is calculating range. Minimum value, maximum value, identify, get the difference. So largest value and smallest value, we get range. If L and S denote the largest and smallest observation, range is L minus S. What is coefficient? L minus S divided by?
L plus S into 100.
Yes, L minus S divided by L plus S into 100. Okay, now I have ungrouped data. I can calculate the maximum and minimum value. In case of grouped data, will I consider class limit or class boundary?
Class boundary.
Class boundaries, yes. So lower class boundary of the first class interval, upper class boundary of the last class interval, the difference of it, we get range. The corresponding relative measure of dispersion is coefficient of range, which is ratio of difference between the two extreme class boundaries to the total of the class boundaries. This is L minus S. This is L plus S. Expressed as a percentage into 100. We get coefficient of range. Then, since range is based only on two observations, it is not regarded as ideal measure, because one of the characteristics of ideal measure is based on all observations. Then range remains, this is common point in all measures of dispersion. They do not get affected due to change of origin, but they do get affected due to change of scale in the same ratio. So if y is equal to a plus bx, what would be the range of y?
Modulus of B.
Modulus of B into
R
f of x.
R of
Yes. This is irrelevant because no change in origin. So B, I'll consider the modulus. I'll ignore the sign. Modulus of B into range of x. Range of y is modulus of B into range of x. Okay. These are the properties of range. This is about range. Clear with this? Yes. Next, we have mean deviation. Mean deviation, yes, when compared to range, this is a better measure of dispersion because here we consider all the observations. We consider all the observations. What is mean deviation? Mean deviation is the arithmetic mean of deviations of the observation from appropriate measure of central tendency. So we can calculate mean deviation from median, mean deviation from mean, mean deviation from mode. Correct? So what would be the mean deviation? If I calculate mean deviation from mean, it would be summation modulus of the deviation. Correct? Absolute deviations. Correct. So it is absolute deviations. So what would be the value? Summation modulus x minus x bar divided by
N.
n, because it's arithmetic mean. Summation modulus x minus x bar divided by n. If I'm using median, modulus x minus median divided by n. Mode, modulus x minus mode divided by n. Okay. If it is grouped, then multiplied with the frequency. That's all. F modulus x minus a divided by capital N. Approaches mean deviation about mean, mean deviation about median. Similarly, we can also have mean deviation about mode. Okay. How do you calculate its relative measure? We know how to calculate its absolute measure. Correct? Its relative measure is coefficient of mean deviation. And how do you calculate coefficient of mean deviation?
Mean
deviation of mean divided by
200.
if it is taken from mean deviation of mean divided by
mean.
Mean.
if it's for median, mean deviation of median divided by median. So basically mean deviation of from a divided by a into 100. What are the properties? In median, we had learned the sum of absolute deviations is minimum when the deviation are taken from
median.
Therefore, the mean deviation would be minimum if the deviation is taken from median. Mean deviation takes its minimum value when the deviation are taken from median. Also, mean deviation, same, change of origin not affected, change of scale it gets affected. Therefore, mean deviation of y will be modulus of b into mean deviation of x. Yes, there is one disadvantage here. There is no mathematical treatment with respect to mean deviation. Further analysis is not possible in case of mean deviation. So mean deviation is difficult to compute, and furthermore, it cannot be treated mathematically. That is one of the disadvantages of mean deviation. Next, we have standard deviation best measure of dispersion. Okay, standard deviation which do not have the demerits of range and mean deviation. So here we consider arithmetic mean always, correct? It is the root mean square deviation when the deviations are taken from arithmetic mean of the observation. So I have taken deviations from arithmetic mean, square of that deviation, mean of that deviation, root of that mean square deviation. So summation x minus x bar divided by n square root. If it is grouped frequency, summation f into x minus x bar divided by capital N square root. If I remove the square root, we get variance.
Variance.
The square of the standard deviation is variance. So for variance would be summation x minus x bar the whole square by n, some f into summation x minus x bar the whole square by n. It is the most useful measure of dispersion and most commonly used. It has some desirable mathematical properties. So basically all the disadvantages of range and mean deviation would be the advantages here. And it can be used to find a pooled measure of dispersion after combining several groups. Combined standard deviation can also be calculated. Relative measure is coefficient of variation. How do you calculate coefficient of variation? Standard deviation by arithmetic mean into 100. Simple. Standard deviation by arithmetic mean into 100. Alternative method of computation of standard deviation, that is shortcut method. In mean we had similarly. Here we'll take A as assumed mean, accordingly calculate D is equal to x minus A by C. Same approach. Then apply this formula. Here we have summation fd square by n minus summation fd by n the whole square. It is same. In normal cases we have summation fx square by n minus summation fx by n the whole square. Here instead of x we will have d. So root of summation fd square by n, summation fd by n the whole square, where d is x minus a by c. Okay, that is standard deviation. What are the properties? If all the observations are constant, what would be the standard deviation?
0.
0.
Zero. There is no deviation. Therefore, standard deviation is 0. Same concept applies to range and mean deviation also. Okay. Then standard deviation, same, not affected by change of origin, but affected by change of scale. Therefore, standard deviation of y will be equal to modulus of b into standard deviation of x. Okay. If there are two groups containing n1 and n2 observations, x1 bar and x2 bar as respective arithmetic mean, s1 and s2 as respective standard deviation, what would be the combined standard deviation?
n1 x1 square plus n2 x2 square plus n1 d1 square plus n1
n2
into
d2
d2
square.
square by n1 plus n2
Yes. So
square.
it is, we have to consider square variance, not the standard deviation. So n1 s1 square plus n2 s2 square plus n1 d1 square plus n2 d2 square divided by n1 plus n1, where d1 is x
minus x bar.
x bar, x1 bar minus x bar. D2 is x2 bar minus x bar. X1 bar is arithmetic mean of first set of observation. X2 bar is arithmetic mean of second set of observation. What is x bar? Combined arithmetic mean. N1 x1 bar plus n2 x2 bar divided by n1 plus n2. Correct. So how do we calculate combined standard deviation? Root of n1 s1 square plus n2 s2 square plus n1 d1 square plus n2 d2 square divided by n1 plus n2, where d1 is x1 bar minus x bar, d2 is x2 bar minus x bar. Clear with this? Now, if we have two groups, this is how we calculate. If we have more than two groups, ni si square plus summation ni di square divided by summation ni. To whatever extent of groups you have, accordingly you have to calculate. Okay. Now, what if the two arithmetic means are equal? If the two arithmetic means x1 bar is equal to x2 bar, then d1 and d2 will be the same. Correct. Therefore, the formula will be n1 s1 square plus n2 s2 square divided by n1 plus n2 square root. So this will not be there. It will be n1 s1 square plus n2 s2 square divided by n1 plus n2 the square root. Okay, this is standard deviation. Any doubts in this? Okay. Last one is quartile deviation. Quartile deviation, again, similar to median, it is the best measure of dispersion for open-end classification. For open-end classification, it is the best measure of dispersion because it will not consider the extreme values. Then it is also less affected due to sampling fluctuation, as it does not include all the values for the calculation. Quartile deviation, same, not affected due to change of origin, but affected due to change of scale. So quartile deviation of y will be
Modulus of B.
Modulus of B into quartile deviation of x.
modulus of b into quartile deviation of x. Okay, so how do you calculate quartile deviation? Q3 minus Q1 by 2. Coefficient of quartile deviation?
Q3 minus
Q3
Q1
minus
into
Q1 by
Q3
Q1
plus
plus Q1
Q2 into 200.
Similar to range. Q3 minus Q1 divided by Q3 plus Q1 into 100. Into 100. Clear with this? Yes, with that, we are done with this chapter also. Chapter 2 is also completed. Okay, so chapter 1 and chapter 2, 50% of the discussion is done. Now we have to move to chapter 3. Before that, we'll take a quick 5-minute break. Yes, we'll assemble at 1 o'clock. We'll resume the class at 1 o'clock. Then we'll quickly finish the other chapters. Okay, guys, are we back?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Okay. So shall we continue? Yes, we'll continue with the third chapter. What was the third chapter?
Probability.
Probability. Third chapter, probability. Broadly, we can divide it into two types: subjective probability, objective probability. What is subjective probability? Subjective probability is based on personal experience, personal judgment. So it is used in case of uncertain situations. Since it is used in case of uncertain situations, there will not be any predefined theories. Therefore, subjective probability is not part of our syllabus. Objective probability is finding out the probability of occurrence of an event based on our history, based on our experience. So we would design theories based on our history, based on the experiences. Based on that theory, we would determine the probability. Objective probability is the probability that an event will occur based on analysis in which the measure is based on recorded observation or a long history of collected data, based on recorded observations, based on our history. Experiment, we have some terminologies which we have to learn. Experiment, what is an experiment? Performance of an event, performance of a particular activity, that is experiment. When we perform an activity, if the result of that particular activity is dependent purely on chance, if it cannot be predicted in advance, if it cannot be if what happens if it cannot be said in advance, then that experiment is called random experiment. So an experiment is defined to be a random if the results of the experiment depends on chance only. Example, tossing of a coin. If a coin is tossed, then we get two outcomes. We can get either head or we can get tail. Before tossing the coin, can we say accurately? No. Therefore, it purely depends on chance. Therefore, we call it random experiment. It is impossible to say in advance whether a head or a tail would turn up when we toss the coin once. Thus, tossing a coin is random experiment. Rolling dice, drawing items from a box containing defects, non-defective items, drawing cards from pack of well-shuffled 52 cards, etc. are all examples of random experiment. Now, what is this event? Event is the result of that activity. Getting a head, getting a tail are events. So if I toss a coin once, that tossing of a coin is an experiment. That tossing of a coin will be considered as random experiment because the result depends on chance. And what are the events of this tossing of coin? What are the results? Getting head or tail. So head or tail are the two events of the random experiment of tossing of a coin. Okay, so events are the results or outcomes of a random experiment. Sometimes events may be combination of outcomes also. So there are two types of events: simple event and compound event. Simple event is those events which cannot be decomposed into further events. They are final. They are the basic events. Okay, so they cannot be decomposed into further. So if I toss a coin once, I'll get one head or I get one tail. I cannot further divide them. Therefore, they are called simple events. On the other hand, composite events are those events which can be decomposed into two or more simple events. For example, I am tossing a coin twice. If I am tossing a coin twice, I can get two events. First one head, second one tail. Second one tail, first one head. Correct? So, or I can get both heads, both tails. These are the events that I get. Here, this head tail or tail head, they can be further decomposed because it can be split into events HT and TH. I can get first head or second tail or first head. So this event of getting one head and one tail can be further decomposed into first head, second tail, second head, so first tail, second head. Confused? Okay, I'll repeat. See, there is one event of getting one head and one tail when I toss two coins. Okay, event of getting one head and one tail. This event is not a simple event because I can have two different situations. Getting one tail can be first head, second tail, or it can be first tail, second head. Therefore, this event A is a composite event which can be further divided into two simple events. So this is simple event. Once I get one head, first head and second tail, I cannot further decompose it. Whereas here, getting one tail and one head, I have two possible outcomes. Therefore, I can divide this composite event into two simple events. Hence, this is called composite event. Clear? Yes. A composite event is one that can be decomposed into two or more events. Getting a head when a coin is tossed twice is an example of composite event, as it can be split into events HT and TH, which are both elementary, means simple events. Okay, then mutually exclusive events or incompatible events. Set of events is known to be mutually exclusive if not more than one of them can occur simultaneously. Okay, this I'll explain with the help of an example. We'll take rolling of a die. So what would be the events?
1, 2, 3.
So these are the possible outcomes: 1, 2, 3, 4, 5, 6. Now, if I take a particular experiment of getting even numbers, then here it would be 2, 4, 6.
Yes, sir.
Getting odd numbers 1, 3, 5. Okay, or I'll take getting prime numbers. Getting prime numbers would be 1, 2, 3, and 5. Correct. So in that case, if can I say these two are mutually exclusive? When we'll say the two events are said to be mutually exclusive, if not more than one of them can occur simultaneously. In this case, can I say event A and B are occurring simultaneously at any point in time?
No.
I can say when I get answer as 2, when I roll a die and get 2 as the final result, then in that case both A and B are occurring simultaneously, because 2 is part of A also, 2 is part of B also. So when we say two events are to be mutually exclusive, the two events will be said to be mutually exclusive when both the events cannot occur simultaneously. Both the events cannot occur simultaneously. So in this case, if I consider odd numbers 1, 3, 5, then both events cannot occur simultaneously, because if 2 happens, if 2 is the value that I get when I roll a die, then A is happening, B will not happen, because 2 is not there here. So when there are no common points, then we can call them mutually
Exclusive.
mutually exclusive. Mutually exclusive. So thus occurrence of one event implies non-occurrence of other. So if A is happening, B will definitely not happen if they are mutually exclusive. Okay, once coin is tossed, we get two mutually exclusive events, head and tail. If head is there, tail will not occur. If tail is happening, head will not occur. Hence, head and tail are mutually exclusive. Similarly, rolling a die, getting an even number and getting an odd number are mutually exclusive events. Okay. Now, second is exhaustive events. Two or more events. I'll take the example of two events only for our understanding. Two events are said to be exhaustive if out of those two, one should occur always. One should occur always. Then they are called exhaustive. Now, in this example, is A and B are exhaustive? Is A and B are exhaustive events?
Yes, sir.
Yes, sir.
Yes, because the possible outcomes are 1, 2, 3, 4, 5, 6. So out of this, I have to get 1, I have to get 2, I have to get 3, I have to get 4, 5 or 6 if I roll a die. So if I get 1, it would be A. If I get 2, it would be, if I get 1, it would be B. If I get 2, it would be A. 3, B. 4 means event A. 5 is event B. 6 is event A. So either event A or event B should happen. Therefore, A and B can be said to be exhaustive events. When will two events A and B will be exhaustive events? When the probability of A plus probability of B is 1. When the probability of both would be 1, we call them exhaustive events. Two events are known to form an exhaustive set if one of those must necessarily occur. As an example, two events, head and tail, when a coin is tossed, are exhaustive because either you should get head or you should get tail when you toss a coin. Therefore, no other event except these two can occur. Okay, therefore they are exhaustive. Last one is equally likely events are mutually symmetric or equiprobable. Two events are said to be equally likely when the probability of occurrence of one event is the same as probability of occurrence of another. Equally likely. So in this case, what is the probability of occurring event A? 3 out of 6. Can I say it is 1 by 2? Similarly, what is the probability of occurrence of B?
1 by 2.
1 by 2.
1 by 2. Therefore, can I say A and B are equally likely?
Yes, sir.
Yes.
Sure.
Similarly, tossing of a coin, head and tail, what is the probability of occurrence of head?
1 by 2.
Probability of occurrence of tail?
1 by 2.
So can I say head and tail are equally likely?
Yes, sir.
Yes. So what are equally likely events? Equally likely events are events of a random experiment are known to be equally likely when all the necessary evidence is considered. No events is expected to occur more frequently as compared to other event. So all the events have same probability. Then they are called equally likely. Two events, head and tail, when a coin is tossed, is an example of equally likely because there is no reason to assume that head would occur more frequently as compared to tail. So with this understanding, now everyone understood mutually exclusive, exhaustive, and equally likely. Yes. So with this understanding, we can deep dive into the definition of probability. This is also called as a priori definition or classical definition. Why it is called a priori definition? Because we should have prior knowledge of the events. Unless we have the prior knowledge, we cannot apply this. Simple. We need to know the total number of events. Total number of events. What is the favorable number of events? Favorable events divided by total events, you get the probability. Favorable events divided by total events, you get the probability. So there is limitations with regard to this definition. It is applicable only when total number of events is finite. Because I have to divide it by total number of events. So if total number of events are infinite, I cannot apply classical definition. It can be used only when events are equally likely or equiprobable. So we can apply only to equally likely events like tossing of a coin, rolling of a die, etc. This assumption is made well before experiment is performed. So equally likely event assumption should be there before the experiment is performed. And it has limited applications because of this equally likely concept. It will be used only in coin dice, tossing, dice throwing, drawing cards, because they are also equally likely. 52 cards, drawing one card is 1 by 52 probability, equally likely probability. Where possible events are known well in advance. If I toss a coin, what are the possible events? Head and tail. So I know the possible events. So I can apply this definition. In the field of uncertainty, where no prior knowledge is provided, this definition is not applicable. Points to be noted: probability of events lie between 0 and 1. 0 means if probability is 0, we call it impossible.
Impossible.
Yes. If it is 1,
Sure event.
Sure event. So it should be between 0 and 1 probability. If probability of A is 0, it is impossible. 1, it is sure event. Non-occurrence of event A, we call it A complementary event of A. Non-occurrence of event A. So I can say event A plus probability of event A plus probability of event A complement would be equal to 1. Correct. Therefore, event A and complement of A are exhaustive events. Either A should occur or A complement should occur. So they are exhaustive events. Then odds ratio. Yeah, even odds against and odds in favor. Ratio of number of favorable events to number of unfavorable events. In classical definition, we take favorable by total. Here it is favorable is to unfavorable. Favorable is to unfavorable. So if probability occurrence of event A is 2 by 5, then what would be odds in favor of event A?
1 minus 2 by 3.
Favorable is 2, unfavorable is 3. 2 is to 3. Correct. Similarly, if probability of B is 3 by 7, what would be odds against?
4.
4:3. Correct. Unfavorable is to favorable. 4:3. So ratio of number of favorable events to number of unfavorable events is known as odds in favor, and its inverse is odds against. P/Q are odds in favor. Then the probability of that event. Okay. If they have given 2:3 as the odds in favor, what would be the probability?
2/5.
2 divided by 2 plus 3, 5. P divided by P plus Q. Yes. Okay. Next one is operations on events, set theoretic approach. Here we call the entire set as sample space. Yes. Under the sample space, we will have various events. So sample space is a non-empty set containing all the events of the random experiment. Sample space is denoted by yes. Event A can be subset of yes. So something like this. Yes includes all the events. A would be subset of that. Okay. In that we have union, intersection, etc. What is union? Union is considering all the points of A and B. So A union B would be all points of A and B. If A is 1, 2, 3 and B is 2, 3, 5, what would be A union B?
1, 2, 3, 5.
1, 2, 3, 5. All the points included in A and B would be considered in A union B. Whereas intersection, it is common points.
Common points.
Yes, common points would be considered. So here, if A is 1, 2, 3, B is 2, 3, 5, what would be A intersection B?
2, 3.
2, 3. Common points. 2, 3, 2, 3. Yes, that is union and intersection. For mutually exclusive events, what are mutually exclusive? No common points between them. Therefore, intersection is 0. Right? So A intersection B will be null set, or probability of A intersection B would be 0. Similar to union and intersection, we have one more concept called difference. A minus B. A minus B means I have to consider all the events of A, but exclude those events of A which are there in B also. Common events. So can I say it would be probability of A minus common of A and B is probability of A intersection B. Probability of A minus probability of A intersection B would be probability of A minus B. Probability of A minus B is probability of A minus probability of A intersection B. Understanding?
Yes, sir.
Yes. Okay. Complement of event A is A complement. How do you calculate A complement? If you have sample space is all the events minus A. We get A complement. Right? A complement is S minus A. Two events A and B are mutually exclusive. If they are mutually exclusive, then A union B, probability of A union B will be simple. Probability of A plus probability of B, because no common points. Correct? If there is common point, if they are not mutually exclusive, probability of A union B will be, we have to remove the common point. Probability of A plus probability of B. Then
probability of A intersection B
minus probability of A intersection B. Correct? Probability of A union B is probability of A plus probability of B minus probability of A intersection B. However, in case of mutually exclusive events, probability of A intersection B would be 0. So it would be probability of A plus probability of B. Probability of A plus probability of B. Next one. Okay, similarly, that was for 2 events. If it was for 3 events, if they are mutually exclusive, probability of A plus probability of B plus probability of C. If they are not mutually exclusive, probability of A plus probability of B plus probability of C.
Probability of A intersection B.
Correct?
Probability of B intersection C.
Correct?
Minus probability of C intersection A. Plus probability of A intersection
B intersection C.
C. Correct. So if in case of 3 events, if they are not mutually exclusive, probability of A plus B plus probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of A intersection C minus probability of B intersection C plus probability of A intersection B intersection C. Okay. So if 2 events are exhaustive, we have learned the probability of A plus probability of B is equal to 1. Correct? Therefore, if they are mutually exclusive and exhaustive, can I say probability of A union B is equal to 1? Correct? And if they are equally likely, we know probability of A is equal to probability of B. Correct? So if 2 events A and B are equally likely, mutually exclusive, exhaustive, and equally likely, probability of A is equal to probability of B is equal to 0.5. Similarly, if three events are mutually exclusive, exhaustive, and equally likely, if they are mutually exclusive, probability of A plus probability of B plus probability of C is P of A union B. A union B union C, because they are mutually exclusive. And if they are exhaustive, this probability will be equal to 1. Correct? Since they are equally likely, can I say P of A equals P of B is equal to P of C, which will be equal to 1 by 3? Correct? So that is how we need to analyze equally likely, exhaustive, and mutually exclusive. Okay, so axiotic or modern definition for a sample space S and event A defined on sample space, probability of A is P of A is the probability of A. If P of A is greater than or equal to 0 for every A of subset S, probability of S is equal to 1. Probability of subset is always 1 because it has all the events certain. For any sequence of mutually exclusive events, P of A1 union A2 union A3 so on is equal to P of A1 plus P of A2 plus P of A3 so on. As far as they are mutually exclusive, we'll just add the probabilities. Now, what all we have discussed, it is in the form of theories, addition theorems or theorems of probability. Theorem 1 is for two mutually exclusive events A and B, probability that either A or B occurs is sum of individual probability. P of A union B or P of A plus B is equal to P of A plus P of B. This is mutually exclusive. For any more than two mutually exclusive events, then probability of at least one of them will occur will be probability of A1 union A2 union A3 union AK is equal to probability of A1 plus A2 plus A3 up to AK. Why? Because they are mutually exclusive. If they are not mutually exclusive, for any two events A and B, any two events, this is not mutually exclusive. Probability that either A or B occurs is given by sum of individual probability of A and B less probability of simultaneous occurrence. That is P of A plus P of B minus P of A intersection B. This is stronger than theorem 1 because theorem 3 applies for any event, including mutually exclusive events. For mutually exclusive, this would become 0. Correct? Then, for want of sufficient evidence, generally, if they give mutually exclusive, we can directly add. If they do not give mutually exclusive, it is presumed non-mutually exclusive. So, for want of sufficient evidence, it is wiser to apply theorem 3 for evaluating total probability. We'll generally consider theorem 3 itself for the purpose of calculating union. Probability of occurrence of two events A and B simultaneously is called compound probability or joint probability, which is denoted by A intersection B. Okay, for that compound probability, we have separate discussion. We'll discuss. For any three events, A, B, and C, probability of at least one of the events occurring is P of A union B union C is P of A plus P of B plus P of C minus P of A intersection B minus P of A intersection C minus P of B intersection C plus P of A intersection B intersection C. Then we have compound probability. Probability of occurrence of two events simultaneously or two or more events simultaneously. So that was P of A1 intersection B, A2 intersection A3 up to AK. So before understanding this conditional probability or compound probability, we have to understand two types of events: dependent events, independent events. What are dependent events? Occurrence of one event is influenced by the occurrence of other. Then they are called dependent events. If there are two events A and B, if B is dependent on A, occurrence of one event B is influenced by occurrence of the other event A, then A and B are said to be dependent. If there two are dependent events, probability of B given that A has happened will be probability of A intersection B divided by probability of
A.
This correct? Probability of A intersection B divided by probability of A. Similarly, if A is dependent on B, probability of A given B will be probability of A intersection B divided by
B.
probability of B. Clear with this?
Yes, sir.
However, if two events are not influenced by each other, if one event is not influenced, the occurrence of one event is independent of the occurrence of other, we call them independent events. Then what would be probability of B given A?
Of B
Probability of B itself, because
is not dependent.
correct, because they are not dependent. Irrespective of whether A happens or not, occurrence of B is not dependent. Therefore, probability of B given A is probability of B Probability of A given B is
Probability
Probability
of A. Therefore, if two events are independent, can I say probability of A intersection B is probability of A into B?
Yes, sir.
Yes.
How do we say that? Because probability of B given A is probability of A intersection B divided by probability of A. We know for independent events, probability of B given A is probability of B. Correct? So cross multiply probability of B into probability of A is probability of A intersection B only for
Independent events.
independent events. Correct. Independent events. So independent events, if occurrence of second event say B is not influenced by occurrence of the first event say A, then B is said to be independent of A. Probability of B given A is probability of B. Probability of A given B is probability of A. Probability of A intersection B is probability of A into probability of B. Correct. Similarly, A intersection B C will be probability of A intersection probability of B intersection probability of C. Why? Because they are independent events. Clear? Okay. So if two events A and B are independent, then A and B complement is also independent. A complement and B complement are also independent. A complement and B are also independent. All those combinations are also independent. Okay. So whatever we have learned, same thing, theory. For two events A and B, probability that A and B occur simultaneously is given by product of unconditional probability of A, that is P of A, and conditional probability of B given A, probability of B given A. Probability of A intersection B is P of A into P of B given A. What is P of B given A? We have already discussed. For any three events A, B, and C, probability that they occur jointly will be probability of A intersection B intersection C in case of dependent events. Probability of A into probability of B given A into probability of C given A intersection B. Probability of A, B given A, probability of C given both A intersection B. Okay, that is intersection of three events in case of dependent events. In case of independent events, P of A intersection B is P of A into P of B. A intersection B intersection C is P of A into P of B into P of C. Simple. Clear with this? Everyone clear till here?
Yes, sir.
Yes. Okay. Okay. One more important discussion, very important from examination point of view. De Morgan's law. P of A union B is 1 minus probability of A complement intersection B complement. While solving the problems also, many places we have used this. Examination, very important, frequently asked question. So we have to apply this to solve the question. So we have to keep in mind this particular formula. Okay, this is about probability. Next, we have random variable at the extension of this, which is continued in the next chapter. What is a random variable? It is a function defined on the sample space associated with a random experiment, assuming that any value from R and assigning a real number to each and every sample point of the random experiment. Random variable is denoted by capital letter C. Okay, A getting even numbers. This is a random variable because function defined on the sample space associated with the random experiment. Correct? So any value defined in the sample space, part of the sample space, we call it random variable. Two types of random variable depending on the discrete random variable, continuous random variable. What is discrete random variable? If it is defined on the discrete sample space, we call it discrete random variable. Can assume either a finite number or countably infinite. Same concept. Number of accidents, number of heads, etc. What are continuous random variable? Defined on continuous sample space can take uncountably infinite number of values. Example, height, weight, etc. Okay. Now, in case of variables, we have frequency distribution. Correct? In the first part of the session, we discussed. In case of random variables, we have probability distribution. We have probability distribution. In normal frequency distribution, we have X values, frequency values. Here we will have X values and corresponding probability values. Instead of frequency, we have probability. This probability value, also called as f of x, probability function. In case of discrete random variable, we call it probability mass function. In case of continuous random variable, we call it probability density function. So probability is expressed as function of x. It's called f of x, probability mass function. In case of continuous random variable, We call it probability density function. Probability mass function, probability density function. Now, in case of frequency distribution, I have x and f, fx, summation f, I get arithmetic mean. Correct. Similarly, here I have x and p, I'll do x into p, summation x into p, we get arithmetic mean. This arithmetic mean is called expected value. Why it is called expected value? Because these are probabilities. This is not the final arithmetic mean, it's only expected mean. Therefore, we call it expected value. Expected value or mathematical expectation or expectation of a random variable may be defined as sum of products of different values taken by the random variable and corresponding probability, x into p. So expectation of x is summation p into x. Expected value x square will be p into x square. What would be its standard deviation? Standard deviation in the normal scenario would be summation fx square by n minus summation fx by n the whole square. Correct. Similarly, here, since it is variance, I'm not putting the square. Here, summation fx square will be expectation of x square. Correct. Minus what is summation fx square by n? This is expectation of x the whole square. Arithmetic mean the whole square. So expectation of x the whole square. Therefore, variance of x would be expectation of x square minus expectation of x the whole square. What is expectation of x? Summation?
Px.
Px. What is expectation variance of x? E of
E of x.
x square minus
E of x whole square.
E of x the whole square. Clear with this? Okay. Now, same in measures of central tendency dispersion chapter. For measures of central tendency, if y is equal to a plus bx, y bar will be equal to a plus b into x bar. Similarly, E of y will be equal to a plus b into E of x, because E is arithmetic mean. Expected value is nothing but mean. Similarly, there in measures of dispersion we had discussed, any measure of dispersion, standard deviation of y will be into standard deviation of x, modulus of b into standard deviation of x. Same. Standard deviation of y is modulus of b into standard deviation of x. Same property holds good for expected value also. What are the properties? Same properties. Expectation of constant is k. If I have same values, then the expected value will also be k. Expectation of sum of two random variables. So if I have expectation of x plus y, I can call it expectation of x plus expectation of y. Similarly, expectation of xy, product of two random variables, expectation of x into expectation of y, or product of one constant and one random variable, E of k into x would be k into expectation of x. K into expectation of x. So expectation of two random variables, E of x plus y is expectation of x plus expectation of y. E of k into x, k is constant here, not a variable. K into x would be k into expectation of x. Expectation of xy, product of two random variables, would be expectation of x into expectation of y. Clear with these three? Okay. With that, we are done with this chapter of probability. Same discussion, theoretical distribution, theoretical probability distribution. Here, all the probability distribution would be built based on theories, what has happened, based on knowledge about a situation. With the theoretical probability, you don't actually conduct an experiment. Instead, you use your knowledge about a situation, some logical reasoning, and or known formula to calculate the probability of an event happening. Experimental approach to probability relies upon actual experiment and adequate recordings of the occurrence of certain events. With theoretical probability, attempts to predict what will happen. Based on the theoretical probabilities, we will predict what would be the expected frequencies of the distribution. Correct. So what would be the definition? We may think of probability distribution. We're just like distributing the total frequency to different class of intervals. Probability distribution. What is probability distribution? Distributing the total probabilities to various values of the experiment. Correct. Total probability is 1, which would be distributed to different mass points in case of random variable, discrete random variable, different class intervals in case of continuous random variable. Such probability distribution that we construct is called theoretical probability distribution using theoretical concepts. Okay, it is called theoretical probability distribution. What are the uses? it may be regarded as a sample, theoretical probability, observed frequency distribution. Observed is constructed based on our observation, based on collection of data, etc. So that is treated as sample because at the end we will be collecting limited data. Correct? So it will be treated as sample, whereas theoretical distribution would be treated as population because it is based on historical data. By fitting theoretical probability distribution, the lamp as a sample, a representative part of a large unknown boundless universe or population, and we may be interested to know the form of such a distribution. And moreover, in certain cases, practically we cannot test all the units. By fitting a theoretical probability distribution to an observed frequency distribution of, say, lamps produced by manufacturer, it may be possible for manufacturer to specify the length of the life of the lamps produced by him. He need not check everything. Based on his past experiences, he can construct a theoretical probability distribution and can predict. Correct? So it can be used in case of testing the lamp. Similarly, testing missiles. We cannot test all the missiles. Correct? Therefore, we can use this concept of theoretical probability distribution. Short-term projections can be made, and statistical analysis is possible only based on theoretical probability distribution. Setting confidence limit or testing statistical hypothesis about population parameter is based on probability distribution, the population under consideration. Okay. Types of probability distribution we have discussed. Based on if it is discrete random variable, discrete probability, continuous random variable, continuous probability. Under discrete, if you want to construct discrete probability distribution, you can have two. You can consider two: binomial distribution or Poisson. If you want to construct a continuous probability distribution, normal distribution. In our syllabus, this is the discussion. There are various other continuous probability distributions also. Okay, binomial distribution, very simple and important from the examination point of view. When we will use binomial distribution, if these conditions are satisfied, there should be only two events. Those two events are mutually exclusive and exhaustive. Two mutually exclusive and exhaustive events, success and failure. And they should be independent. Trials are independent. Probability of success is P. Probability of failure would be considered as Q, which is 1 minus P. These two will not change throughout the experiment process. And number of trial N is finite. Finite positive integer. If all these conditions are satisfied, then only I can go with binomial distribution. What are the conditions? Mutually exclusive and exhaustive outcomes. How many outcomes?
Outcome.
Only two outcomes. Only two mutually exclusive and exhaustive outcomes. Trials should be independent. P and Q should not change throughout, and N should be finite. If these conditions are satisfied, I can go with binomial distribution. So how will I calculate the probability? I'll calculate the probability based on this function. F of x is equal to NCX into P to the power of
x into the power of n minus
Q to the power of N minus X. So here N is number of trials, the number of trials that we do. X is the probability what we want, the function that we want. P is success, Q is failure, which would be constant. So using this, we can find out the probability function for each variable. Thereby we can construct the probability distribution. Yes, so a discrete random variable x is defined to follow binomial distribution with parameters n and p. To be denoted by x follows binomial with n and p are the parameters. Two parameters in case of binomial distribution, n and p. Why they are called parameters? Because if I know n and p, I can find out the entire binomial distribution. Correct? So binomial distribution, two parameters, n and p. Okay, properties. N is greater than 0. P and Q should be greater than or equal to 0 because they are probabilities, and all probability functions should be greater than or equal to 0, and also total of this f of x should be equal to 1. Total of all the probabilities should be 1. And binomial distribution is biparametric distribution, two parameters n and p. Mean is given by n into p, variance is
npq.
npq, correct. Variance is npq. Mode depends on what is my n plus 1 into p value. If n plus 1 into p is integer, then it is bimodal. Bimodal. What would be the two modes? N plus 1 into p value and n plus 1 into p minus 1 value, the previous value. Those two are the modes. If it is not an integer,
IS12.
then it is unimodal. The highest value in the integer would be the mode. So if the value that we got is 10.22, 10 is the mode. Here, if the integer n plus 1 into p is 10, 10 and 9 are the mode. Clear? Yes, variance is NPQ. Then variance is maximum when P and Q are 0.5. Variance is maximum when P and Q are 0.5. Though, then what is the maximum value of the variance? Maximum value of variance is n into 0.5 into 0.5. Or I can say n into 1 by 2 into 1 by 2, which is n divided by 4. So n divided by 4 is the maximum variance of that particular probability distribution. Okay, then since P and Q are numerically less than equal to 1, we can say NPQ is always less than NP. NPQ is always, variance is always less than mean. Then binomial distribution is symmetrical at P is equal to 0.5. If P is 0.5, then the distribution would be symmetrical. If there are two distributions, X and Y, if X follows binomial distribution, Y follows binomial distribution, then I can consolidate those two. X plus Y will also follow binomial distribution. Will also follow binomial distribution. Okay. So when do we apply binomial distribution? When trials are independent, trials have just two outcomes, success and failure. Example, coin tossing, sampling inspection plan, genetic experiments, and so on. So basically there should be two, success or failure, only two outcomes. Okay, fitting of binomial distribution, method of moments method, the formula that we follow, method of moments. Poisson distribution. Simple to remember, binomial distribution, those four conditions have to be satisfied. If those four conditions cannot be satisfied, if it is a discrete random variable, apply Poisson distribution. So Poisson distribution is a theoretical discrete probability distribution which can describe many processes, given by Simon Denis Poisson of France, 1837. So a random experiment under the following condition is considered to be Poisson model. If the following Poisson model, if the probability of finding success in a very small time interval is k into t, where k is constant, then probability having more than one success is very low. Probability having success is independent. So basically what are they saying? N should be large, P is very small. In that case, we generally apply Poisson distribution, because in that case, binomial distribution cannot be applied. How do you calculate the probability here? E to the power of minus kt, k to the power of x divided by x factorial. Instead of kt, we can also use m to the power of minus m to the power of x by x factorial. What is E? 2.71828.
2.718.
2.71828. Clear with this? Okay. What is m? We'll discuss. M is the parameter of the Poisson distribution. Poisson distribution has only one parameter, because once I get m, I can find out all the probabilities. Since e to the power of minus m is greater than 0, it follows that f of x is greater than or equal to 0 for every x. Summation f of x should be equal to 1. Total of the probability should be 1. It is uniparametric. Parameter is m. What is the mean of the Poisson distribution? M. What is variance? It is also 1. Sorry, variance is also m. So mean is equal to variance in case of Poisson. Mode again depends on what is the value of m. If value of m is an integer, then mode is m and m minus 1. If it is a non-integer,
Highest value in integer.
Highest value in the non-integer m. That would be mode. Okay. Then Poisson approximation to binomial distribution. If n of a binomial distribution tends to infinity and p tends to 0, so that m is equal to np. How to convert a binomial distribution into Poisson distribution? We have to equate m is equal to np and then correspondingly calculate, construct the Poisson distribution. When we will do this? When n tends to infinity, p tends to 0. Then we convert or approximate binomial to Poisson. Similarly, additive Poisson distribution, additive property, two distributions a and b, sorry, x and y. If x follows Poisson, y follows Poisson, I can say z is equal to x plus y also follow Poisson distribution. Application: when number of events n is very large, probability is very small. In that cases, we'll apply examples. Very important. Look into these examples: printing mistakes, road accidents, radioactive elements, demands in case of a health center. Okay. Fitting of a poson. Same method of moments to fit the posons. The formula that we know, we'll apply that formula. First, for that, we need to calculate M. Poisson distribution is uniparametric. We equate M, the parameter of Poisson distribution, to be to the arithmetic mean of the observed distribution and get the estimate. So M is mean. Binomial distribution, what is mean? NP. So I'll equate M is equal to NP and get the M value. For that, we can construct the Poisson distribution. Last one, normal distribution or Gaussian distribution. Two distributions, what are we have discussed. Binomial and Poisson are for discrete. For continuous, it is normal distribution. So in case of normal distribution, we apply continuous distribution, we apply normal distribution. What are the two parameters here? Mu and sigma square. Mu and sigma square. Formula to calculate the probability, f of x is 1 divided by sigma root 2 pi into e to the power of minus x minus mu the whole square by 2 sigma square. Okay, we need not by heart this, but remember that this is the approach that we have to follow. In certain cases, I think we had solved one problem wherein they had given us this value and asked us to calculate the probability. Properties of normal curve. It is a bell-shaped curve, one peak. It will be something like this. So bell shape with one peak. Since it has only one peak, we can say that it is unimodal. Correct. Then this is mu. If I draw a line at mu, then we get two equal parts. So I can say normal distribution is symmetrical at x is equal to mu. Line drawn through x is equal to mu has divided the normal curve into two parts which are equal in all respect. Such a curve is called symmetrical curve. Distribution is called symmetrical distribution. Normal distribution is symmetrical about x is equal to mu. Binomial distribution is symmetrical at p is equal to 0.5. So binomial distribution p is equal to 0.5. Normal distribution x is equal to mu. Then we say the distributions are symmetrical. And these two tails never touch the axis. They go infinitely, but in the decreasing order. On both sides, both left and right tail never touch the horizontal axis. Total area under the normal curve is 1. Total area is 1. Correct. This is mu. If we consider this is mu, this would be minus infinity. This is infinity. Mu to infinity, what is the area? Because it is symmetrical, 0.5. And from minus infinity to mu, it is 0.5. Correct. If we consider mu as 0, standard deviation as 1, then we get standard normal variable. We get standard normal variable. That distribution will be called standard normal distribution. Then accordingly, wherever mu is there, you put 0. Wherever sigma is there, you put 1. You get this particular formula for calculating standard normal, for probability of the standard normal variables. Z is called standard normal variable or standard normal deviate. Normal distribution is biparametric, mu and sigma square. So mu and sigma square are the parameters of normal distribution. What would be the parameters of standard normal distribution? What is mu in standard normal distribution? 0. What is sigma? 1. So can I say 0 and 1 are the parameters of standard normal distribution? Yes. So mu and sigma square are the parameters of normal distribution. 0 and 1 are the parameters of
Standard
normal distribution. Parameters of standard normal distribution. Yes. Okay, next one. Properties of normal distribution. Mean, median, and mode are all are equal at mu. Mean, median, mode of normal distribution coincide, all being equal to mu. Standard deviation sigma. Mean deviation sigma into root of 2 divided by pi, or if it is sufficient, if you remember, 0.8 sigma. So standard deviation is sigma. Mean deviation is 0.8 sigma. What would be quartile deviation? Quartiles Q1 is mu minus 0.6375 sigma. Q2 is mu plus 0.6375 sigma. Quartile deviation is Q3 minus Q1 by 2. So can I say?
So that is Q3.
Q3, yes. Q3 minus Q1 by 2. Correct? Quartile deviation is Q3 minus Q1 by 2. So if I do that, mu will go off. So I'll get 2 into 0.6375 sigma divided by 2. 2 goes off. Can I say quartile deviation is 0.6375 sigma? So standard deviation is sigma, mean deviation is 0.8 sigma, quartile deviation is 0.6375 sigma. Clear with this? Sorry, 675 sigma, not 6375 sigma, 675 sigma. Clear with this?
Yes, sir.
Yes, sir. Yes, sir.
Yes. Now we have 2 points of inflections. Point of inflections are the points at which it changes the curve. It changes the curvature. The normal curve will change the curvature. So how do I calculate the points of inflection? It is mu minus sigma, mu plus sigma. Mu minus sigma, mu plus sigma. In standard normal distribution is -1 and +1. Then, okay, 99.73% of the value of the normal variable lies between mu minus 3 sigma and mu plus 3 sigma. Probability that value of x lies outside the limit is as low. So between mu minus 3 sigma and mu plus 3 sigma, you will have 99.73% of the values. If x and y are independent normal variable with mean and standard deviation as mu1 and mu2 and standard sigma 1 and sigma 2 respectively, then z is equal to x plus y also follows normal distribution. Same. If x and y are normal distribution, z x plus y will also be normal distribution. Okay, properties of normal distribution. It is the utilization application is wide, not only restricted to statistics, various other subjects also will have this application: science, social, management, commercial, etc. Most of the continuous variable follow normal distribution. When n is large and p is moderate, when n is large and p is moderate, when n is large and p is small, binomial distribution tends to Poisson. When n is large and p is moderate, binomial distribution tends to normal. Correct? Then Poisson when m approaches infinity. When m is large, Poisson distribution approaches normal distribution. Such transformation becomes necessary as it is easier to compute the probability. So these 2 points are important. Everyone understood when binomial tends to Poisson, when binomial tends to normal? Yes. Okay. Standard normal distribution, if continuous random variable follows standard normal distribution, to be denoted by z follows n of 0, 1, probability mass density function of that standard normal distribution. What are the properties? Now, same. What would be the mean, median, and mode of standard normal distribution? They are equal, obviously, we know.
0.
0. What is the variance?
1.
Since variance is 1, standard deviation is also 1. Then what would be mean deviation?
0.8.
0.8. Sigma is 1. Correct. Quartile deviation 0.675. Quartile deviation 0.675. Then it is symmetrical at z is equal to 0 because mu is 0. Symmetrical at 0. Points of inflection -1 and +1. They never touch the horizontal axis. If x bar denote arithmetic mean of random sample of size n drawn from normal population, z is root of n into x bar minus mu by sigma. One additional formula that we had discussed. Okay, this is about theoretical distribution. The second set is also done. Now we'll have to move on to the last set. Any doubts still here?
No, sir.
Okay, fine. The last set, correlation, regression, and index numbers. Very simple 2 chapters. What is correlation? Understanding the relation between 2 variables. Helps us to find an association or lack of it between the 2 variables. And regression is using that relationship. We'll define a relationship. Using that, we will predict the future values. That is regression. So to understand correlation regression, we generally use bivariate data. So we have to understand what are bivariate data. Bivariate data are data collected for 2 variables simultaneously. 2 variables simultaneously. They are called bivariate data. Frequency distribution is called bivariate frequency distribution or joint frequency distribution. 2-way classification. If x and y denote marks in maths and stats for a group of 30 students, then x and y, the distribution of x and y is called bivariate distribution. Correct? So we have marks in stats, marks in maths, right? We had 0 to 5, 5 to 10, 10 to 15, 15 to 20 as the class intervals. 10 to 15, 15 to 20. Now, If I take out the entire distribution of marks in stats, this total, it is called
Marginal.
Marginal distribution.
marginal distribution. It is called marginal distribution. Instead, if I take the marks in stats, if the marks in maths is 10:15, 10 to 15, then it is called
Conditional distribution.
yes, correct. Conditional distribution. It is called conditional distribution. So marginal distribution is a frequency distribution of one variable across the other variables full range of values. Conditional distribution, frequency distribution of one variable across particular subpopulation of the other variable. Subpopulation when marks is 10 to 15. So with that, correlation. What is correlation? While studying two variables at the same time, if it is found that change in one variable is reciprocated by the corresponding change in the other variable, either directly or inversely, then two variables are said to be associated or correlated. Otherwise, if there is no relationship, they are called uncorrelated or independent. Types: positive and negative. If two variables change in the move in the same direction, positive correlation. If two move in the opposite direction, negative correlation. Okay, two variables are known to be uncorrelated if movement on part of one variable does not produce any particularly deterministic movement of other variable. Measures of correlation, we discussed four. First one is scatter diagram. Scatter diagram, where we can use it only to identify whether there is correlation or not. We cannot measure the correlation. Correct? That is scatter diagram, simple diagrammatic method to establish correlation between the pair of variables. Unlike product moment correlation coefficient, this can measure correlation only when variables are having linear relationship. Unlike, oh no, this is reverse. Product moment correlation coefficient can measure correlation when there is linear relationship. Scatter diagram can be applied for linear as well as non-linear. What is linear? What is non-linear? We have discussed. Linear means the change happens in the same direction. Non-linear, there can be change in the directions also. Right? So linear and non-linear. When scatter diagram can be used for linear or non-linear?
Both, sir.
Both. Scatter diagram for both linear and non-linear. Whereas next one, product moment, it can be used only for
Linear.
linear. Clear with this?
Yes, sir.
Yes, great. So scatter diagram can distinguish between different types of correlation. It can help us to identify whether it is positive or negative or no correlation, but it fails to measure the extent of correlation. Totality of all the points form the scatter diagram. Pattern of the plotted points reveal the nature of the correlation. Positive correlation means plotted points, it would be something like this. From lower left to upper right. Negative means it would be something like this. Upper right to lower left. Sorry, upper left to lower right. Zero correlation, no particular pattern would be there. Okay. Next, to measure correlation coefficient, we have Carl Pearson's product moment correlation coefficient, as we discussed, only in case of linear. How do you calculate? This is ratio of covariance and the product of standard deviation of the two variables. So covariance of xy divided by standard deviation of xy into standard deviation of y. What is covariance of xy? Summation x minus x bar into y minus y bar by n, or summation xy by n minus x bar into y bar. Correct? So the same concept if we apply, n into summation xy minus summation x into summation y. We had discussed the derivation of these formulas. Correct? Whole divided by standard deviation of x, n summation x square minus summation x the whole square into n summation y square minus summation y the whole square is a formula to calculate correlation. In case of bivariate, wherever you have xy, you had f. Wherever you have x, you multiply it with f. You get bivariate, covariance, bivariate, standard deviations. Then we have properties. Correlation coefficient, since at the end of the day it is expressed in the form of decimals, that is, it should be between -1 and +1. It is unit free measure. So it is not affected by units, and it should be between -1 and +1. -1 and 0 is negative correlation. 0 to 1 is called positive correlation. Correlation remains invariant. Change of origin, change of scale, it doesn't get affected, but it only gets affected by sign. The sign of the correlation might change if the values of B and D are of opposite sign. Correct? If B and D, so if U is equal to X minus A by C, V is equal to Y minus B by D. Sorry, yeah, X minus A by B and Y minus C by D. Correct? Wherein B and D are called change in origin or scale.
Scale.
Change in scale, because we are dividing. So if B and D are of different signs, then the correlation of U and V will be negative of correlation of XY. If B and D are of same signs, then correlation of U and V would be
Same.
correlation of XY. How do you calculate B and D? The equation that they have given, we have to convert it into this form so that we get B and D values. Then check whether B and D are positive, are of same signs or of different signs. If they are of same signs, then same value would be the correlation. If they are of different signs, then the correlation would be the opposite sign. Clear with this? Next one, Spearman's rank correlation, where it is generally used in case of qualitative characteristics. Qualitative characteristics in case of ranks, rank correlation coefficient can also be used to find level of agreement or disagreement between judges. However, it doesn't mean that we cannot use it for quantitative. We can still use it for quantitative, but for calculation, first we have to allot ranks to all the values. Correct? As compared to product movement correlation coefficient, rank correlation coefficient is easy to compute. It can be advocated to get a first-hand impression about the correlation between the pair of variables. Simple to compute. No much calculations involved. So what is the formula? 1 minus 6 summation d square divided by n into n square minus 1. We know what is n, number of values, number of observation. What is d?
Difference between the ranks.
Yes, d is difference between the ranks. In case of tied ranks, then we have to additionally give effect to this. We have to calculate the t cube minus t divided by 2 value 12 for each of such tie. What is t? Length of the tie. If the ranks 2 is tied for 3 values, then for this it is 3 cube minus 3 by 12. If rank 5 is tied for 2 values, 2 cube minus 2 by 12. So similarly, how many ties are there? You accordingly calculate this value, add, that would be added to d square, summation d square. So it would be 6 into summation d square plus summation t cube minus t divided by 12. Apart from that, the formula would remain the same. So everyone understood what should be done in case of tied ranks? Yes, we had solved problems also regarding that. Then the third one is coefficient of concurrent deviation. Here, we are not bothered about the amount of deviation. We are only bothered about the sign, positive correlation or negative correlation. So what we will do, we will give positive sign if there is positive increase in the value. We give negative sign if there is a decrease in the value. Then we'll multiply the signs of both x and y. We get the product of the signs of x and y. So we know plus and minus, minus and plus, plus and plus, minus and minus. Only if they're of same signs, we get the final product as positive. If they are negative signs, we get negative. These positive signs are called concurrent deviation. The deviations are concurrent to each other. Concurrent deviations, which we will denote as C. Total of the positive signs will be C. Total of all the deviations would be M. Correct? Total number of concurrent deviations C. Total of the deviations would be M. M will always be 1 less than N, because for the first value we will not have any deviations. Will not have any signs involved. So M is equal to N minus 1 and C is total of, what is C?
Positive signs.
All positive signs in the product column. Once we have that, we'll apply this formula to get the correlation coefficient. What would be the sign? Sign depends on 2c minus m value. If 2c minus m is positive, correlation will also have positive value. 2c minus m is negative, correlation will also be negative. Clear with this? Then
Yes, sir.
last part of this chapter, regression analysis. In regression analysis, we are concerned with estimation of one variable for given value of another variable based on mathematical relationship between the two variables. When two variables x and y, and if y is influenced by x, then we get a simple linear regression. Y dependent variable, x is independent variable. So in that case, what is the regression equation if y is dependent on x?
Y is equals to a plus bx.
Correct. Y is equal to a plus bx, and this b is called byx. Correct. Regression equation of y on x.
Yes.
Regression coefficient of y on x. Sorry. Regression coefficient of y on x. Here a and b are the parameters. A and b are the parameters. B is called regression coefficient of y on x, denoted by byx. Byx is covariance of xy divided by variance of x. Yx, simple, because at end it is x, so denominator should be x. So covariance of xy divided by variance of x. Covariance of xy can also be calculated as r into standard deviation of x into standard deviation of y divided by standard variance of x. Standard deviation of x and 1 of standard deviation of x goes off. So regression equation of y on x can also be calculated as correlation coefficient into standard deviation of y divided by standard deviation of x. Or if we have covariance, covariance of xy divided by variance of x. Once you have b, how do you calculate a? Using this concept, y bar is equal to a plus b into x bar. So here I want a is equal to y bar minus b into x bar. With this, we get a. With that, we can design the regression equation of y on x. Similarly, regression equation of x on y, it would be x is equal to a plus b into y. Here b is xy. Correct? Bxy. And accordingly, a same concept. Bxy r into standard deviation of x by standard deviation of y, or covariance of xy divided by variance of y. Then how do you calculate a? X bar minus b into y bar. Same concept. So if we have understood byx, bxy calculation will be same. Clear with this? Yes.
Yes, sir.
Next, properties of regression coefficient. Here it is not changing by it's not changed due to shift of origin, but changes due to shift of scale. Change in scale gets affected by change in scale. So if u is equal to x minus a by b and v is equal to y minus c by q, since it is affected by change in scale, byx is equal to, since y is there, first take this q by p into vu. Similarly, bxy is equal to, since x is there, take p by q into buv. Accordingly, we get the regression coefficient of the changed variable. Clear with this? Okay. Two lines, two regression equation. Okay, if I want to calculate the arithmetic mean of the two regression equation, just solve the equation. The answer would be x bar and y bar. Correct? And alternatively, I can also calculate correlation coefficient. C is byx into bxy. Correlation coefficient is byx into bxy root. Basically, it is the geometric mean of those two. Sign depends on the sign of bxy and bfx. They are positive, r is also positive. If they are negative, r is also negative. Clear with this? Okay, last part. Probable error. Correlation, a calculation of correlation for population based on the correlation of the sample. Obviously, it will not be the same. There will be some fluctuation. That fluctuation we'll calculate. The fluctuation is called probable error. How do you calculate probable error? 0.6745 into 1 minus r square divided by root n. So we have to by heart this. We have no option. 0.6745 into 1 minus r square divided by root n. Alternatively, 2 divided by 3 into standard error. Standard error is again this one, 1 minus r square divided by root n. So first we have to calculate probable error. Probable error is the fluctuation. Probable error is 0.6745 into 1 minus r square divided by root n. Once you have probable error, we can predict the correlation coefficient of the population, which will be equal to r plus or minus probable error. So we'll have upper limit and lower limit of the correlation coefficient of the population. So R plus probable error would be the upper limit, R minus probable error would be the lower limit of the correlation coefficient of the population. What is R? What is R? Correlation coefficient of what? Correlation coefficient of the sample. Correlation coefficient of the sample which we have calculated. P is the correlation coefficient of the population which we are estimating based on the correlation coefficient of the sample. Simple. Okay. Assumptions while probable errors are significant. If R, the correlation coefficient of R sample, if correlation coefficient of sample is less than the probable error, then we can say that there is no correlation. If R is greater than 6 times the probable error, then correlation coefficient is certain. High correlation coefficient. Okay, so if R, since R lies between -1 and +1, probable error can never be negative. Okay, probable error formula is valid only if the sample that we have chosen is a random sample and the population is normal. Random sample, population is normal, only then we can consider this particular formula of probable error to estimate the correlation coefficient of the population. Okay, last part, review of correlation and regression analysis. If two variables x and y are independent, then we say correlation coefficient is 0. But if correlation coefficient is 0, I cannot say x and y are independent, because product movement correlation coefficient only looks into linear relationship. There might be non-linear relationship between x and y, which is not computed by Carl Pearson's product movement correlation. Therefore, if x and y are independent, then obviously correlation coefficient should be 0. But correlation coefficient 0 doesn't mean that x and y are independent. There might be non-linear relationship. So we can only say if R is 0, if the correlation coefficient is 0, we can say that there is no linear relationship between them. There is no linear relationship between them. Then, in some cases, we may find correlation between two variables. Although they are casually related, they are not directly related. They are related because of 1/3 variable. So directly there is no correlation. Such correlation is called spurious correlation or nonsense correlation. Spurious correlation or nonsense correlation. Positive correlation between production of rice and iron for 20 years. So in that case, there might be a correlation that we get, but rice and iron production are not related. Rice and iron production, we are getting a correlation because of those 20 years data. Because of that third variable, we are getting the correlation between these two components, which is called spurious correlation. Okay, then coefficient of determination. Coefficient of determination is R square. R is correlation, R square is determination. So if R is 0.6, R square is 0.36, which means that there is a change in the value of the total change, 36% change. I know what is the reason. 36% change is only accounted for. A correlation coefficient measuring a linear relationship between the two variables indicates the amount of variation of one variable accounted for by the other variable. Better measure for this purpose is provided by the square of the correlation coefficient, known as coefficient of determination. Coefficient of determination R square, how do you calculate? Explained variance by total variance. Total variance is the total change, of which how much I know, that is explained variance. Explained variance divided by total variance. Value of 0.6 for R indicates 36% of the variation has been accounted for by the factor under consideration. Remaining 64% variation is due to other factors. So if coefficient of determination is R square, what would be coefficient of non-determination? 1 minus R square. 1 minus R square. It is nothing but this is the total percentage of variance for which I have no answer. I have no explanation. Coefficient of non-determination. Regression analysis is concerned with establishing a functional relationship for making future projection. This can be applied, unlike correlation, for any type of relation. Regression equation can be applied for linear as well as non-linear. Correlation, Carl Pearson, can be applied only for linear. Correct? Yes. Two lines of regression equation coincide. That is, there will be only one regression equation when R is -1 or R is +1. If R is 0, regression equation would be perpendicular to each other. If R is 0, regression equation perpendicular. If R is +1 or -1, regression equation coincide. Clear with this? Yes, with that, we are done with that chapter also. Last chapter, a small chapter and easy chapter. Index number. What is index numbers? Index numbers are nothing but ratio of prices or commodities or values, as the case may be, expressed in terms of percentage. Expressed in terms of percentage. Here we have two time periods, current period and
Base period.
base period. Base period values will always be 100, correct. Base period value will always be taken as 100, and accordingly we'll calculate the current period values. Two or more time periods are involved, one of which is the base time period. Value at the base time period serves as standard point of comparison. So it will be used as a point of comparison. An index time series is a list of index numbers for two or more periods of time, where each index number employs the same base year. Index numbers are studied here because some techniques for making forecasts use index numbers, and they are unwieldly. Then okay, fine. Broad classification, simple and composite. If there is only one variable, simple index number. More than one variable, composite index number. Correct. Now, that is with regard to classification of broad classification of index numbers. To construct index numbers, we have certain criteria to be considered. Selection of data, very important, because index number is based on data, correct? And most often we consider sample. So selection of sample have to be very careful. Random sampling, specifically stratified random sampling, have to be considered, and it should be comparable. It should be comparable. The data should be comparable. Base period. Selection of base period is very important. The period that we select should be normal. There should not be any abnormal or extraordinary events that have occurred, and it should be relatively recent. Base period will always be considered as 100. Selection of weights. Some components will have some lesser weightage, some components will have higher weightage. We cannot give equal weightages. So appropriate selection of weightages should also be made. Correct. Use of average. Generally, we go with average, since we have multiple commodities and we have to have one single value as the index number. We have to go with average. Which is the most appropriate average for index numbers?
Geometric mean.
Geometric mean is the most appropriate. However, for ease of calculation, we go with
Arithmetic.
arithmetic mean. Choice of variables, whether we want wholesale price, whether we want retail price, depending upon the purpose for which index number is being prepared, we have to appropriately choose the variables. That is the fifth property. Last, selection of formula. We have various formulas. Selection of appropriate formulas. These are the issues that we have to consider in construction of index numbers. Clear with this?
Yes, sir.
Yes. Index numbers notation is fine. Price relative. What is price relative? Current price divided by base price into 100. Quantity relative, current quantity divided by base quantity into 100. Value relative, current value, base value to 100. What is value? Price into quantity. Value is price into quantity. Okay, so these are three relatives: price relative, quantity relative, and value relative. Okay, now if I consider P1 divided by P0. Next year, if I consider P2 divided by P1, successive prices or quantities are taken at base, then we call it link relative. If the bases are fixed, we call it chain relative. Correct? Then methods of construction of index numbers. We have aggregate method, average of relative method, under aggregate, simple aggregate, weighted aggregate. Under average of relative, simple average of relative, weighted average of relatives. Simple aggregate is simple. You have three commodities, total all the prices of the three commodities, current year, prices of the commodities, base year, Pn, summation Pn divided by summation P0 into 100. Correct? That is how we calculate simple average, simple aggregate method. Aggregate all the values. Easy to understand. If units are changed, index number will also change. That is a disadvantage. Whereas simple average of relatives, here we do not go with totaling the prices. Instead, calculate the price relative for each commodity. For each commodity, you calculate Pn by P0 into 100. for A, for commodity B, Pn by P0 into 100, for commodity C, Pn by P0 into 100, then total these index numbers, then divided by 3, average, simple average of relatives. So one way to rectify the drawbacks of simple aggregate index is to construct simple average of relatives. Under it, we invert the actual prices for each variable into percentage of base period. These percentage are called relatives because they are relative to the value for the base period. Index number is the average of all such relatives. One advantage is that they are pure numbers. Index numbers are pure, free from units. Price index numbers are computed from relatives, will remain the same regardless of the units. So if units are changed, we need not bother about it. And it meets the criteria of unit test. Subsequently, we have what are unit tests, etc. Quantity index can be constructed for group of variable which are expressed in divergent units also. What is the disadvantage? Here, we are giving equal importance, equal weightage. Correct? So which amounts to undue weightage given to the commodities which is used in small quantities. For that, we have weighted aggregate index numbers. Here, to meet the weakness of simple methods, we weigh the price of commodities based on suitable factors. We give weightage. The weightage used will be either quantity or value. Generally, we use quantity as the weights. Correct? Then choice of one or other will depend on the importance. There are various formulas. Last pair, Pache, Marshall index, and Fisher. Last pair, base year quantity. So it would be summation Pn Q0 by summation P0 Q0 into 100. Quantity would be the weight, base year quantity. Past check, current year quantity. So Pn Qn, divided by P0 Qn into 100 because current year quantity, right? Marshall Edgeworth average, correct? So Q0 plus Q1 divided by Q0 plus Q1. That price would remain the same, current year, base year. Fisher, he'll do the geometric mean of last pair and past check. So it would be summation Pn Q0 by P0 Q0 into Pn Qn by P0 Qn into 100 square root. So these are the 4 formulas under weighted aggregate. Weighted average of relative, simple. Summation Pn Q0 P0 Q0 into P0 into Q0. That is the weightage that we have to give. Divided by summation P0 Q0 into 100. When we simplify the formula, we get the same as last pair.
Last pair.
Summation Pn Q0 divided by summation P0 Q0 into 100. Clear with this?
Yes, sir.
Yes. Okay. Chain index numbers. Now we want to change the base. But if we change the base frequently, we cannot compare the index numbers. To ensure comparability also, we go with the concept of chain index numbers. There we have 2 concepts. First, we have to calculate link index. How to calculate link index? P1, P0 into 100. P2, P1 into 100. P3, P2 into 100. Correct? We have link index. Then we calculate the chain index. Chain index, this formula. This link index into chain index of the previous year divided by 100. Chain index for first year would be 100. And obviously link also will be 100 for the first year. Link relatives reveal annual changes. Then we have quantity index numbers. Instead of price, we'll take quantity. So simple aggregate Qn by Q0, simple average Qn by Q0 divided by N. Weight, same last pair, past year, Fisher. Under last pair, what is the weight that we give? Base year price. Here current year price. Fisher, geometric mean. Weighted average of quantity relative, same. Last pair. We can go with last pairs. Value indices. Value is price into quantity. So value index number is summation Pn Qn divided by summation P0 Q0 into 100. Okay. With that, limitations of index numbers. Yes, we know the advantages. The advantages are more. What are the limitations? Since we take samples, the sampling errors cannot be avoided. Then some selected items, they may depict the broad trend, not the real picture. Since it is some selected items, they'll have the trend. We can understand the trend, but we cannot understand the real picture. Then, since many methods, the result which gives, so selection of the formula would impact the index number. So since many methods are employed for constructing index numbers, the result gives different values and this creates confusion. So these are the 3 limitations. Sampling errors does not give the real picture, but only the broad trend. and its selection of different formulas create confusion. Usefulness of the index number. What are the usefulness of index numbers? Framing, it is used in framing suitable policies in economics and business. Then reveal trend and tendencies, important conclusions, forecasting future economic activities, long-term trend, time series analysis, seasonal variation, used in deflating. What is deflating? We'll discuss subsequently. Then cost of living index numbers measure change in the cost of living over the given period of time. So basically in all economic decision making, index numbers will be used. What is deflation? What is deflating here? Deflating is bringing the current value to the value that would be there if we had the same inflation rate as the base year. Same inflation rate as a base year. Now, base year is 100, current price is 120. The current price of that commodity is 6,000 rupees. I cannot say if it was 5,000, it becomes 6,000. I cannot say there is a 20% increase in the price of commodity. I have to first bring this down to 100. If this is at 120, what would be at 100? Then compare with the real increase in the price. That is deflating. How do you calculate current value by price of the current year? Current value into base price by current price. So in this, how we had to calculate 6,000 by 120 into 100? We get the deflated value. Clear with? Yes. Shifting and splicing. Okay. Shifting the index number is, I have base year as 2010. I want to shift it to 2015. How do we shift? Now consider 2015 as 100. Then recalculate all the index numbers. This refers to two technical points. How base period may be shifted, how to index covering different bases may be combined into single series by splicing. So shifted price index, original price index divided by the price index of the year on which it has to be shifted into 100. Original price index 120 divided by price index of the year on which it has to be shifted into 100. We get shifted price index. Splicing two sets of price index numbers covering different price. Okay, what is splicing? I have the index numbers for two different sets of index numbers. 2006 to 2011, I have index number with 2006 as base. 2011 to 2020, I have two index numbers with 2011 as base. I have to combine both. How do I combine? I'll take 2011 as base and calculate the index numbers for all these. Then you will get the combined. That is called splicing. Clear with this? Yes. Last is test of adequacy. We have 4 tests: unit test, time reversal, factor reversal, and circular test. Unit test is, it should be irrespective of the units. It should be irrespective of units. Okay, there is some mistake. This is wrong. Okay, it's there in the material, the normal caps material, it's there. Unit test is, it should be irrespective of the unit, should not get affected by the units. All index numbers are satisfy unit test except one. Which one?
Simple aggregate.
Simple aggregate, correct. Simple aggregate does not satisfy the unit test. Time reversal test is going forward and backward. P01 into P10 should be equal to 1. To determine whether a given method will work both ways in time, forward and backward, formula for calculating index number should be such that two ratios, current on the base and base on the current, should multiply to unity. P01 into P10 is 1. P01 is index number for 1 on 0. P10 is index number of 0 on 1. Which satisfies this? Only Fisher. Okay. Next one is factor reversal test. Factor reversal test is price index into quantity index should give us value index. Price index into quantity index should give us value index. If this is satisfied, we say factor reversal test is satisfied. Again, only Fisher's index will satisfy this. Since Fisher's index satisfies time reversal and factor reversal, it is called ideal index numbers. Clear with this? Time is P01 into P10 is 1. Factor is P01 into Q01 is equal to V01.
V01.
Yes. Then circular test, simple. I had calculated the index number 1965 as the base. Okay, 100. Index number of 1970 is 200. I have calculated. Then 1960 was the original base. At 1960, 100, 1965 index number was 150. Now, can I calculate 1970 index number with 1960 as the base? I can calculate. It is just again splicing, correct? This, if it satisfies by cross multiplying, if it satisfies, then we say circular test is satisfied. Okay, if we by cross multiplying, if we get the correct answer, we say circular test is satisfied. Measurement of price changes over a period of years when it is desirable to shift the base. This property enables us to adjust the index value from period to period without referring each time to original base. We need not refer to the original base every time. We can just multiply the values. This is called circular test. None of those 4 measures satisfy the circular test. Only one, simple geometric mean of price relatives. We have simple arithmetic mean, simple average of price relatives. In that, simple geometric mean of price relative and weighted aggregative with fixed weight meets this test. Circular test satisfied by only 2, simple geometric mean of price relative and weighted aggregative with fixed weight satisfy this test. Clear with this? Yes. Okay. With that, we have completely discussed the entire portion of statistics. Yes, I took half an hour more, I agree. With the 3.5 hours, we have discussed completely the entire portion of statistics. Was it useful?
Yes, sir.
Yes, sir.
Yes, sir. Very much.
Yeah. Okay. Now what we have to do is we have completely refreshed the concepts, solve some problems. Solve the problems so that the concepts what you have learned, you have discussed would be permanently stored in the memory. Clear with this? Okay.
Yes.
Anyone has any doubts? Anything to ask general related to statistics? Okay, then fine. Okay, shall we conclude? Yes. Thank you, guys.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you so much, sir.
Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Happy Diwali, sir.
Happy Diwali, sir.
Yeah, same to you.